to try to protect animals and to prevent cruelty to animals. And that was followed quite soon afterwards, 2 years later, by the formation of the Society for the Prevention of Cruelty to Animals, which then became the RSPCA when it got a charter from Queen Victoria. So this followed on really a lot of discussion about not being cruel to animals. But then in 1872 we had Charles Darwin, who of course is famous for many things, but also wrote this thesis on the emotions of animals and man, or man and animals. So he began to think not only should we not be cruel to animals, but perhaps there's something else that animals have. And this is illustrated with some really beautiful pictures of what animal emotion might look like. So this animal is described as being humble and affectionate from the way it's behaving. So it started to think that animals have these properties, these characteristics. And quite soon after this, there again more legislation, more thinking about how we might protect animals, and maybe starting to think about that animals' lives might be important to animals themselves. If we jump forward a few more years, in 1911, there was a piece of legislation, Act of Parliament, passed to protect animals. So we're not just thinking about the absence of cruelty, but we're actually thinking about protecting, caring for animals. And that's enshrined in legislation. And this piece of legislation has been superseded by other bills since then, but this is really the grandfather, if you like, of animal welfare legislation in the UK. Obviously, quite a few things happened very soon after 1911. It was a pretty turbulent time over the next few years. And there was a big revolution in agricultural production and the animals that we would have in our lives. And this really brought about a massive shift in how we looked after animals. A move from extensive animals living in pastures towards housing animals and looking after animals in a much more intensive way. And this led in the 1964 to a really quite remarkable woman, Ruth Harrison, who wrote a really influential book called Animal Machines, which some of you might be familiar with. And she was horrified by what she saw in terms of how animals were looked after, intensive agriculture. And so she wrote this book that was really an expose of the way that we were thinking about animals. And that book was really influential. It had a massive impact on the public. There was a public outcry about the way food was being produced. And that led to this document, which is a pretty dry-looking document to be something pretty revolutionary. But it was a report from a technical committee that were asked to look at the welfare of animals kept under intensive livestock husbandry systems. And that committee was chaired by Brambell. So that is the origin of this report that came about 50 years ago. So this was a pretty dry document. You can imagine that that would be something useful to put you to sleep at night. But within that, containing that, are some really important things that the committee found, which has really shaped the way we think about animal welfare over the last 50 years. So they accepted explicitly that animal can feel emotions. So all the last 200 years of discussions about whether animals had emotional states or not were accepted by this committee, that it was undoubted. They accepted that animals could experience emotions, and there was no justification for disregarding animal emotions. They accepted that these may not be the same as the emotions that humans might feel, but they are substantial, and the animals can experience things such as rage, fear, apprehension, frustration, pleasure. So really quite complex emotions. They were accepting that animals could experience these. They also made it very clear that although disease is of course extremely important for animal welfare, it was not the only issue. So animal welfare is not just animal health. You can be a healthy animal but still have poor welfare. And they were very clear about that in this report. They were also very concerned about the inability of animals to perform natural behaviours, or behaviours that were important to those animals due to the degree of confinement. So again, they were thinking about behaviour as an important part of animal welfare, being able to perform behaviours that the animal felt was important, or they were highly motivated to perform. And they explicitly, again, rejected the idea that animal production alone was an indicator of good welfare. So they had several representations from egg producers and from other producer bodies saying, these animals are laying eggs every day, therefore they must be in good welfare. And they, again, rejected that as an idea. So it's not sufficient for an animal to be producing. There's something more in animal welfare. And again, from our point of view, again, they were also very concerned about the evidence base. So it wasn't an emotional response to animals, it was looking at the scientific evidence, scientific investigation of animal welfare was important in terms of how we would decide what is an appropriate way to look after animals. So this was a really influential document, and what happened next? Well, there was various different events. There was a society founded in Edinburgh, the Society for Veterinary Ethology, in 1966, which is now still going strong. It's now renamed the International Society for Applied Ethology. And just a little plug in for the fact that we will be hosting the 50th anniversary Congress in Edinburgh next year to celebrate that. There was also an Act of Parliament, the Agriculture Act in 1968, which again redefined the terms of animal welfare within that Act. And there was the production of the first code of recommendations for the welfare of livestock, all flowed from this report about animal welfare. Another really important thing, something we're really going to look at this morning, is the setting up of the Farm Animal Welfare Council, as it was then called, as it was called then, and it's now the Farm Animal Welfare Committee. And they produced, based on the text that Brambell and its committee had produced, they produced the 5 freedoms. So this isn't a manual for assessing welfare, but this is an idea about what we should be aiming to achieve in the lives of animals. What are the things that are important to animals that we need to take into consideration? And so another key part of this is that they're not talking about the inputs that we give to animals. So the first freedom is the freedom from hunger and thirst. It's not providing food to animals. It's about the experience of the animal when food is not there or water is not there. It's about the discomfort they may feel if their living quarters are not appropriate. It's about the fear and distress that they may experience if they're treated badly. And it's also about their ability to express their normal behaviour, as well as pain, injury and disease. So what we're going to cover this morning is really to look at these 5 freedoms and how we've moved on from thinking about these, what sort of work is being done at the moment to try and understand what this means and how we can understand these lives of animals. So I think really the Brambell Report has been important in defining our science as animal welfare scientists. And there are, I guess, some key things that came out of that report that we still are really important to the work that we do today. So behaviour is central to understanding animal welfare. It can be a tool to understand animal emotional states, but also there's a recognition in the 5 freedoms that if an animal is not able to perform a behaviour that's important to it, that can cause poor welfare. So behaviour and expression of particular behaviours is important for welfare. Again, there's this idea that of course disease and health is really important, but it's not enough to understand animal welfare. So we have to balance animal health with other aspects of the animal's mental life or mental suffering. And really the key part of animal welfare science is to assess animal emotional states. So that's what animal welfare is for the animal. It's the way it thinks, feels and experiences the world. So what we're going to try and do this morning is to cover some of these different ways that we might go about understanding that. And so we have a pair of talks for each of the 5 freedoms. And so the first talk will tell you a little bit more about that freedom, what it means, how we might think about it. And the second talk will tell us a little bit about some of the current research that's going on to try and understand that and working in that area. So I think for each talk we have the pair of talks, and then there'll be an opportunity to ask questions after each of the pairs for each of the freedoms. So we're going to move on to thinking of the first freedom, so that's the freedom from hunger and thirst. And I'd like to invite Dr. Rick Deeth to come and talk to us about hunger, obesity, thirst and over-drinking. Thank you.
Thank you, Kathy. Is this on? No? Let's try again. How about now? No? Good. Right. Okay. So this is the title of my talk: Hunger and Obesity, Thirst and Overdrinking, the Challenges of Nutritional Management in Captive Animals. So the freedom from hunger and thirst is the first of the 5 freedoms, and it's, as well as just being those words, it also includes the words by ready access to fresh water and a diet to maintain full health and vigour. So I've taken into my remit to include some unhealthy diets relating to overeating and the problem of obesity. So in simple terms, when my animals not get enough food or water, well, for the animals in our care, one case is when the caregiver just doesn't provide enough food and water. So cases of neglect and abandonment, like this poor skinny dog here, and the work of animal charities that take them into their shelters, rescue centres to look after them, rehabilitate these kinds of animals, is very important. And of course, people that do this, they're breaking the law now under the new 2006 Animal Welfare Act that requires that they have a duty of care to look after these sorts of things. Sometimes the caregiver can't provide enough food or water, so in cases of natural or man-made disasters such as drought, snow, floods, earthquake, or even war, then obviously the animals can be in real trouble then. And this is and again, there's international charities like World Animal Protection and IFOR that have taken it upon themselves to go into these disaster situations and try and take care of the affected animals. Now let's look at how we recognise hunger and thirst. So let's look at thirst first of all. So there are some physical signs, some obvious physical signs such as dry lips and changes in skin tension, things like that, but they vary between species. The gold standard test is to do a blood test of plasma osmolality, but also a sort of simple diagnosis and remedy of the problem of thirst is just to offer animals water, and a thirsty animal is going to drink water. For farm animals, the UK welfare codes require permanent or at least daily access to water, depending on the species, and typically will specify the number of drinkers or troughs so that animals can access water whenever they like. How do we recognise hunger? Well, unlike some of the other freedoms where we might hope to, our aim might be to completely abolish perhaps disease or pain. In the case of hunger, there's a certain amount of normal hunger that happens on a day-to-day basis. Animals eat and drink in meals. When they've just finished a meal, they're probably not going to be suffering from hunger, and it's okay for them not to have food or water. But when a period of time passes where an expected meal time is missed, then that's when an animal might start to feel a little bit of short-term hunger. And these kinds of daily meal patterns can be a simple guide to us to make decisions about, for example, what's a suitable journey time during animal transport, or is it okay to take my cat to the vet for a few hours without giving her any food or water? Probably yes, because she seems to eat sort of once or twice a day, as far as I can tell. In the longer term hunger, where this can happen when limited food means that animals will start to use their body energy reserves, so reserves like glycogen in the liver and fat. And we know that in wild animals and in some farm animals, there's a certain amount of seasonal weight loss that's normal. So some fluctuation in weight over the seasons. So, for example, these sheep in winter, they might be losing a bit of weight because they can't access food at that time. And at some point, that's going to eventually result in poor welfare. Animals' behaviour in terms of their preferences and motivation tells us they are much, much more affected by long-term hunger than short-term hunger. What about the other end of the spectrum? When we overfeed animals, this can result in obesity. So this affects humans and companion animals or pets, horses, zoo animals. And the problem here is that evolution has just not equipped us to cope with the obesogenic environment, where it's more common. I mean, maybe some of you were down the gym last night, or perhaps hunting a mammoth with a spear. But more likely, I suspect, like me, you were sitting on the sofa feeling hungry whilst watching British Bake Off. So, of course, that's the obesogenic environment. The sofa, plentiful, tasty food, hungry food, making us hungry. It's tempting, and combined with inactivity can result in obesity for some of us. and we're overfeeding our pets. Zoo animals, of course, the challenge there is probably inactivity as well. So dealing with obesity, one of the first challenges is to recognise it in the first place. So some of the pet food companies are putting out these scoring systems, body condition scoring, to sort of try and highlight what a normal cat should look like. You know, that a normal cat actually has this sort of this shape here to its tummy, rather than this sort of more like a rugby ball shape. There's also a specific problem, in sort of hidden problem, I suppose, of the risk of obesity in adult breeding farm animals, and this results from genetic selection for rapid growth for meat production. So chickens and pigs in particular, they grow very, very fast. They're given loads of food, and they're slaughtered when they're still really quite young. They're still juveniles. So broiler chickens are slaughtered less than 6 weeks old, pigs less than 6 months old. So way before they reach adulthood. So this genetic potential for rapid growth and a large appetite is a problem for their parents, because they have to live much longer and produce the eggs which become the broiler chickens and produce the piglets that grow into the meat pigs. So broiler breeders and sows have a real problem. And these animals, instead of being fed ad libitum like their offspring, fed as much as they want to eat, their diet, their food is restricted in quantity typically to avoid obesity. And that can result in concern over hunger for those animals. How do we recognise hunger in the long term? Well, so physical changes such as weight loss, or again body condition scoring. So just looking at visible signs, changes in the body fat reserves, like this cattle body condition scoring system on the right here. But also behaviour. We see hungry animals, they really increase their activity, particularly foraging activity, and that sort of foraging or oral behaviour can become abnormal. So stereotypic oral behaviour, where you see like repeating patterns of the same behaviour, like this bar chewing sow, or over drinking, where the animals drink a lot more than they normally would, perhaps in order to receive oral stimulation, or possibly because they're seeking some sort of gut feel. Hungry animals also show high motivation for food and for opportunities to forage, as I'll talk about a little bit more in the next slide. And they show physiological changes, which Ian's going to talk about more. Ian Dunn will talk about more in the next talk. So in the research that I've been doing with Ian Dunn and others, we've been measuring motivation for food or for foraging in hungry broiler breeder chickens. And so this is based on the idea that animals will work for things that they want when they're motivated. And so to measure hunger in broiler breeder chickens, we use a water runway, where chickens are asked to pay a cost of walking through water. And getting wet is something that they really don't like, as shown by this cartoon. But when they're prepared to walk through the water, then they can receive a reward, which is an area of wood shavings where they can peck and scratch to explore for food and express their natural foraging behaviour. So this is a diagram, a side view of the apparatus that we use, with a start platform on the left there, and we ramp down into the water, and a ramp up onto the foraging platform where they can peck and scratch. And you can see that in the photo below, the chicken on the left on the start platform, contemplating whether to walk down that ramp across that little puddle of water there in the middle, and up onto the foraging area there on the right that you can see. But what we can do is over successive tests. So in the experiment I'm about to show you, we used 8 successive tests where the foraging platform gradually moved further and further away, and the water got gradually deeper and deeper. So we can make it more of a challenge, increasing the cost and really probing the motivation of the animals, find out how hungry they really are, or whether they're willing just to give up. So here's some data from an experiment with broiler breeder chickens. So on the left-hand side there, the y-axis, you'll see the proportion of birds reaching the foraging area that are prepared to cross the water. And then on the x-axis, 8 successive tests where the water gets gradually deeper, so just deep enough to cover their feet, and then sort of towards up to chest depth on the right there. What you see is that the blue line shows the commercial restricted birds that are fed the usual amount that they would get in a farm, and then we've got the red and green lines show birds that are fed 2 or 3 times that amount. And you can see that the birds, the hungrier birds, the feed restricted birds, they're much more willing to cross the water even when it becomes deeper and longer. So how do we solve the problem of obesity? Well, there are three approaches. One is just to reduce energy intake by restricting food quantity. So it means providing less of the same food. And for your obese cat, that might be just following the recommendations on the side of the packet, feeding them the correct, for the type and age of the animal, the correct amount. The other way to prevent obesity is to restrict energy intake, this time by reducing food quality. And by food quality, I don't mean sort of cheap, rubbishy food, I mean something like energy density. So cutting out the high energy dense, high sugar, high fat foods, like in the human context, these sort of sweet bars, replacing that with more like high fibre foods like salads and wholemeal bread. And so for pets, that might mean sticking to the sort of correct pet food and not giving them table scraps from the table, like this cat being offered food from a plate. But also that there are diets that you can buy for pets that would include this one here that's been marketed as a high fibre diet to boost satiety. So the idea here being that these higher fibre diets, they're perhaps better for welfare because the animals might feel more full when they eat them, compared to just reducing the quantity of food that they get. The final approach to preventing obesity is to have a situation where the food can take more time, energy, and effort to obtain. So here we're talking about, to some extent, reducing energy intake, but also increasing energy expenditure and the time over which animals are feeding. So this includes things like scattering or hiding the food, or puzzle feeders, and this is often something that you see in zoo animals, as shown in the pictures here. I'm not sure what's inside that cardboard box zebra. But it's quite anyway, so this kind of foraging enrichment potentially can also increase species typical behaviours and provide stimulation. So that sort of relates to the freedom to provide to perform normal behaviour. Finally, I should say that restricting food can have the inadvertent side effect of increasing social competition. So in sows, that's often solved by using individual feeder spaces, like in the top picture, or sometimes electronic feeders where the individual animal ID is recorded by the machine, and the machine will give the portion, a fair portion, to every sow in the group, and avoid the situation where the dominant animals can get access to most of the food. And in broiler breeder chickens, you can get these spinner systems like the one shown in the picture, which will scatter feed over the floor of the shed over a large area, again ensuring that everybody gets a fair chance to feed. So there's been some progress in the freedom from hunger since the Banner Report. Some legislative changes that have happened. So for ration-fed pregnant sows that I've just been talking about, the EU regulations now require a sufficient quantity of bulky or high fibre food, as well as high energy food. So they're sort of acknowledging that when you've got to feed restrict an animal, sometimes it's better for welfare to maybe give it more high fibre food, or at least opportunities to forage in fibre. And Ian's going to talk about this a little bit. But we know that the broiler breeder industry are also looking at alternative diets to boost satiety. Although there's no legal requirement about that yet. There are some relatively extreme feeding practices that have been banned in the UK and in lots of other places, but not everywhere in the world. And those include forced molting of laying hens by providing no food at all for 7 to 14 days, which actually results in the birds shedding their feathers, growing new feathers, and it boosts egg production. But that's completely banned here. Also, the forced feeding of geese and ducks to produce fatty liver or foie gras, banned in lots of countries, including the UK, but not everywhere. I'd like to thank my many collaborators and students and funders that you can see on this slide. Thank you.
Thanks very much, Rick. If you have an urgent question, can you just hold on until we move on to the next talk, which will be given by Ian Dunn from the Roslin Institute, and it's already been trailed by Rick that this will be a continuation. We're looking more at the the physiological, what happens in the brain to understand hunger.
Yes, is that a bit on the loud side? Okay, so I am going to start my talk. Oh, no, I'm going to start somebody else's talk. Okay, yes, so I'm going to try and talk a little bit about what we are trying to do in the case of the broiler breeder. And I just included this picture that Paul Hocking produced when they were setting up broiler layer crosses at the Institute here. And it's just to remind you that the birds that we eat as meat are very different from the birds that lay eggs that we eat. And there's been, as Rick said, a huge genetic selection in both directions. And it's just that some people don't appreciate that, and it's quite important in why the problem exists. And so, as it says, we're going to look into the brain and try and understand, sorry, if I stand over here, we get a horrible noise, what's going on when restricted feeding occurs. And because of that huge efficiency in terms of producing meat, these birds are producing about a third of the world's protein from animals. And in this little graphic from the National Geographic, it's thought that at least just on chickens, that there's about 52 billion chickens killed every year for food. And to get 52 billion chickens, it's maybe apparent that you need at least 52 billion eggs. And if you don't feed restrict the parents, the ovary will look like this. And although you might think more follicles, the yolk effectively in the egg is good, these do not produce fertile eggs, or they don't hatch. So the ovary should look like this, and this is one of the reasons that they're restricted, as well as the health of the parents. Now, I put this in just to show, I mean, these are some food-restricted broiler breeders. They're very nice birds. If you're used to working with birds, they're very attractive. They appear healthy. And they grow continuously through their life, and they produce eggs. Although, as Kathy said, production isn't necessarily end in terms of welfare. If they were not food restricted, they would grow like this. In the studies some of the studies we've done, there were no actual reliable measures that we found, particularly of stress in these birds, but I guess that's still an open question. But they certainly show a very strong motivation to feed, and during the rearing period, the degree of restriction is very large. Maybe they're eating 25% of what they would choose to eat. So what can we do about it? Well, one thing, certainly Paul Hocking here and myself have spent quite a bit of time over the years, was trying to see if we could disconnect the reproductive consequences of selection from the growth consequences. And I guess we've not been overwhelmingly successful in that pursuit. So we're looking much more at the moment at the dietary dilution, the qualitative restriction that was mentioned by Rick. And in that regard, the question is, although you can qualitatively restrict these birds and they'll have the same growth characteristics as the quantitatively restricted birds, does this actually reduce the feeling of hunger in these birds? And so I suppose I'm just concentrating in this talk on the aim that we had of trying to find biological markers that would actually allow the appraisal of this satiating effect of alternative diets that Rick mentioned. And I've got to take you through a very brief excursion into the brain and how food intake is controlled. And this is very well conserved in us as well as in birds. Down here there's something called the infundibular nucleus. It's also known as the arcuate nucleus, because I happen to mention that because I notice I've used that later on. And there's a set of neurons that express this POMC, propiomelacortin. When you've got lots of food, this axis is dominant, and it, through this product alpha MSH working through a receptor, it decreases food intake, so it's anorectic, if you like. When you, and there's a competing set of neurons that express AGRP, agouti-related protein, that antagonize this effect. And if you have only 1 grain of corn to eat and you're hungry, these predominate and cause increased feed intake by antagonizing the effect of this product at the receptor. And it's AGRP that we're going to talk about for the rest of the talk, the marker that we're using in the brain. And so the question is AGRP a good marker of satiating effects? And we set this experiment up to try and separate in broiler breeders the effect of body weight and feeding experience. And we restricted the birds normally, i.e. as it's done in commerce, 6 weeks of age, and then we let one group feed ad libitum, other groups were kept restricted. We had 1 and the 2 times restriction, which Rick was one of the diet levels that Rick mentioned, and we let a group come off restriction so that they were the same body weight at the time that we killed the birds at 12 weeks of age. And here we also have a group that were just removed from restriction for 2 days, and they, although they appear to be a different weight, it's explained by the crop content. Birds have a crop that stores food. This was full of food because they had ad libitum access and they hadn't had that, so that explains that difference. So we had birds that were the same body weight with different experiences of food intake. And what was the result? Well, you can see very clearly AGRP differs enormously in the brain when the bird is restricted to when it's ad libitum fed. And if we look at the birds that are the same body weight, again, a big difference between the ad libitum and the restricted birds in the different paradigms. But there's also, within that, we know there are differences between how long the birds have been on ad libitum feeding. So we can see birds that were on for 6 weeks, 2 days, or 2 weeks. We get a nice gradation of expression of the mRNA for this gene. So what about the solution that we're being proposed of dietary dilution, called qualitative restriction, which is what Rick said. And birds take a long time to eat these diets, and I'm not a behaviourist, so I have to be very careful, but they appear to not to show some of the behaviours associated with quantitative restriction, and this picture shows that quite nicely. Rick mentioned drinking. These birds are restricted, and they've been drinking a lot, so the litter is very dark and poorer quality, whereas these, it's friable, and these are on the oat hull diluted diet, but the birds are the same body weight, same growth. And this was a pilot experiment in here measuring it, but we did get some amelioration, if you like, in terms of AGRP expression. So it did appear that the qualitative restriction was having some effect in the direction that we might want. But we're repeating these experiments to see if that's true. And how would this work? Well, gut fill is one option. We used a different fibre called ispagula husk. You might be familiar with it if you've got constipation, or you might not want to admit that, but anyway, it forms a gel. You don't need to give very much of it, and it certainly fills up. This is the duodenum. Here's an ad lib, and this is a restricted bird. So in it, you can see here the crop fill. It's not quite at the ad libitum level, but this is a short-term paradigm. But in this case, certainly no difference in AGRP. So at least in that experiment, it doesn't appear that it's the gut fill itself. So there may be something specific about the oat hulls in the longer term that if it does have an effect. So just to summarise this piece, because AGRP distinguishes between hens that are the same body weight but with different experiences of food intake, ad libitum versus restricted, it does appear to be quite a good indicator of satiety. And we have some optimism that qualitative restriction may be able to reduce the drive to eat, at least at the level of the brain. And obviously we're doing the behavioural experiments that Rick mentioned as well. And that's what's next. We're trying to integrate those behavioural measurements with the neurochemical measurements in the brain, particularly to look at these diluted diets to see if they have a desirable effect. And as Rick also said, we're working with industrial partners to try and look at some of the practical diets that they think they can produce that will have this effect, a lot to do with reducing protein and energy density, but obviously they need to maintain the reproductive potential of these birds. And I think the other thing that we are trying to do, and this is, while I said that the central things are conserved, a lot of the peripheral feedback of satiety from the gut principally seems to be different in birds, and these are some of the things we do know, but there's a lot of things we don't know about this, so we're trying to understand more about that. And so just to conclude, I think AGRP expression certainly offers the hope that we can develop relatively simple methods of determining satiety and appraising it, and hopefully to be able to tell the difference between how these animals are seeing their experience with all the different treatments and food intakes. And understanding ultimately what mediates satiety in birds hopefully can help us understand this paradox between the problem of welfare. If you don't restrict them, they will die or become ill and not reproduce, but against the potential for hunger that exists. And so it's just to thank again all the people who've actually done these experiments here at Roslin, Newcastle, and of course at SRUC. So thank you.
Thanks very much. We have time for a few questions on the first freedom. Could I ask that I have a couple of glamorous assistants carrying microphones, that you wait for the microphone to arrive so that we can get it on the recording. We also have the option, I think, from the people listening on the web to ask questions if they wish as well. So, questions for Rick or Ian?
Where's this one?
Or this one?
What's that?
I actually have a question for each of you. I don't know
I don't know if it's on.
Yeah, that's working.
it's full battery.
Okay.
Maybe I'll start from Ian. Have you looked at the different expression levels in broilers versus layers?
Not specifically. We have for some genes in the pathway to do with what they call the second order neurons, and there was some differences. I think what more tellingly we've done is to look at, we know there are certain genes that have been selected for in broilers versus, well, actually, to be fair, it was done long before the broiler industry. It was when people created the progenitor birds that were used for the broiler industry, and they do, so some of the feedback things have been changed undoubtedly by selection, and it does mean that birds that carry the higher growth alleles have higher AGRP and therefore a greater drive to eat. I think the trouble with comparing layers and broilers, as you can see, take them at the same age, take them at the same weight, it's quite difficult, but with the genetic teasing apart, we can certainly see that there's been selection on things that do change appetite.
Another question for Rick. With the motivation experiment, I was wondering with the dog training, we use food as rewards for work. But over time, especially with sports dogs, with the framework principle, the actual work becomes reinforced itself. So you will see dogs working more for less food and actually sometimes just trying to work for the work itself. Mm-hmm. So if you're performing the same experiments on the chickens where they are required to work to get the food, do you expect to see any kind of similar effect over time?
Yeah, I think they continue to dislike water. Yeah, but it is a problem, I suppose, that if you repeat a test, that it change. Yeah, learning effects can change what happens quite a lot. Interestingly, I didn't dwell on this, but we had no food in that apparatus. Part of the reason is when you've got birds that are on lots of different diets, you're trying to grow them different ways or different growth curves. If you start offering food in a test, then that can mess that up. Also, the mere presence of food can sort of change the motivation, especially as they start to eat it. They can become more motivated. You get sort of short-term feedback. So, for various reasons, we developed a task which actually has no food. It's just a foraging area where they can peck and scratch. With no food present, but it seems to be something they're highly motivated to do, because I guess it's evolutionary adaptive for them to seek food in those sorts of places using the behavioural method that they usually use. Thanks.
Thank you. One final question.
Yeah, I was just wondering.
I can hear you if it's any comfort.
Okay. I was just wondering whether you see the inverse with the POM-C, and why did you choose EGRP over POM-C
Yeah, well,
indicator for satiety versus
POM-C I have to be careful. POM-C, if you use, say, I don't know, what for many people would be a large experiment, but let's say 12, 24 birds, you can't see any difference in POM-C expression. If you use really huge numbers, hundreds, then yeah, you can see but for whatever reason, it doesn't give you it's not sensitive in terms of the measurement of gene expression to changes in food intake. I mean, I guess, and we haven't done it, whether it's more sensitive in other strains, is it something to do with broilers? I don't know, and I mean, those are questions that we could look at, but haven't.
We have looked at MPY though, haven't we? And that sort of changes in a similar way to AGRP, but the signal's not quite as clear.
I thought that the one that would be, sort of inhibiting food intake would show the opposite effect.
Yeah, I mean, it does if you have enough power, but you need an awful lot of power to see it.
Okay, thanks very much for the questions. Obviously, lots of complex biology going on in understanding hunger. I should say that everybody will be here at lunchtime. I hope everyone will be here at lunchtime. And we've got a long lunch, so if you want to ask more questions in more detail, then please feel free to hunt down the scientists and ask them. So we're moving on now to our second freedom, the freedom from discomfort, and Dr. Marie Haskell from SRUC.
Thank you very much, Kathy. I think this is working. My job is just to introduce the second freedom, the freedom from discomfort, because following me is going to be Professor Malcolm Mitchell and Fritha Langford, who are going to talk about the science and the research that's being done. So the freedom from discomfort is kind of talked about a little bit in the Brambell Report, but what really happened was then it was taken up by people like Falk and the legislation, because it's largely interpreted in terms of providing the animal with the right physical environment. So Falk talks about freedom from discomfort needs to be addressed by providing the appropriate environment, including shelter and resting, and these ideas have actually been taken up in the legislation. So you can see in the Animal Welfare Act of Scotland, and the England and Welsh one is very similar, the idea that it's a suitable environment that needs to be provided. And they talk specifically about accommodation, shelter and resting. So really, when you think about discomfort, it doesn't seem like a welfare harm, but obviously a prolonged discomfort can lead to violation of other freedoms. So you might be a little bit uncomfortable now, a little bit hot, too cold, have a cold, disease or something, but these things pass. But it's really when there's continued discomfort that it actually will pass into another violation of the freedom, become pain or distress. So you can really think about animals having a comfort zone, and they will actually work quite hard to maintain themselves in a comfort zone. So movement out of this zone is what we then term as discomfort, and leading on to causing pain and distress. So where is the comfort zone? Well, you can imagine that the animal's biology and its biological systems are set up to maintain itself into a comfort zone. It wants to be at an appropriate temperature, to have enough food, enough water, not too little, not too much, etc. And the biology of the animal over evolutionary history has allowed it to have the mechanisms to keep itself in that comfort zone. So if it's too hot, it might use its behaviour to seek out a shaded area, to seek water, or physiologically it might commence panting or sweating. So discomfort increases when these strategies fail, and that's where the welfare issue comes into it. Are we allowing the animal the resources or the scope or the time to be able to maintain itself in that comfort zone? So have we provided enough water? Have we provided cooler areas or warmer areas that allows it to use these mechanisms inbuilt in order to maintain itself in the comfort zone? And I think this is probably what Fritha and Malcolm are going to come along and tell you. Can animals do that, and how? And in terms of measuring discomfort, we often use these kind of behavioural and physiological mechanisms as indicators. So when we say, okay, cows, what is the most comfortable place for you to lie down, or do you like seeking outdoor access? We offer them a choice. We allow them to show us by their behaviour what they want. So here's an experiment that I'm sure Fritha will talk about, where we said to cows, do you like to go outside? And so we offer them a choice of an indoor area to go and stand up, or an outside area. And we can see what their behaviour is. They show us by moving to one area or another. We can also use the physiology. So this is a thermal image, which I'm sure Malcolm's going to talk about, where we see what the response of the pig is to a warm situation by measuring the temperature of its eyes. So these are measures that we can use, and it allows us to scientifically address the issue of discomfort and what the animal needs to maintain itself into a comfort zone. So that is where I am. These pictures of a cow having a nice lie down and a pig in mud ends my talk, and now I can pass on to Malcolm to talk about the science of discomfort, and Fritha after him. Thank you.
Okay, thanks, Maria. I should have said at the outset that you get 3 for the price of 2 actually in discomfort, so that's excellent news. And our next talk is by Malcolm Mitchell, looking at thermal environment.
Thank you, Cathy. Good morning, everyone. We've heard described very eloquently how discomfort might arise in farm animals. And clearly, for welfare to be optimal in the animals in our care, the environment should not impose undue stress. The environment should therefore not cause the discomfort that we're dealing with in this freedom. But we can all identify many potential factors that might compromise the animal and impose stress and therefore cause discomfort. And my proposition to you this morning is that the thermal environment constitutes a very major threat, a very major risk to animal well-being in a number of situations. And in particular, the risk of heat stress and cold stress. Now, in animal production, there are many situations in which that particular problem may arise and discomfort will occur. That's true of indoor systems, outdoor systems, intensive systems, extensive systems. And often animals in any of those will be exposed to situations where the risk of thermal stress is apparent. It's also very obvious that this situation can be exacerbated when we impose other artificial environments upon the animals that we are caring for. For example, during animal handling and animal transport, and even within the slaughterhouse. Another important aspect of this is, in a world that's ever changing, the risk of thermal stress to livestock is increasing, and we need to develop more understanding and more strategies to enable us to face up to the challenges imposed by what's happening to the climate. So what we need to understand for today is, what are thermal challenges and why are they such a problem? How do the animals respond to the thermal stress? How can we measure these responses and then perhaps model the effects of the thermal environment to understand the welfare consequences for the animals? And then, most importantly of all, how do we take that information and use it to provide real-world solutions? Why do animals experience such a problem when faced with a changing thermal environment? Well, as you see on this illustration, the range of normal body temperature is actually very, very narrow indeed. It's represented by the green part of this bar chart. As body temperature moves outside that particular zone, we start to see some very major changes. And we don't need big changes in body temperature for an animal to become clinically hypo or hypothermic. And of course, tragically, this range of temperatures, which only covers about 20 degrees, is bounded at either end by fatality. So it's very important to the animal to control its body temperature within a very narrow range in order to maintain tissue function, and in particular the central nervous system. All the animals we're concerned with produce huge amounts of metabolic heat, and they produce this throughout their body, and it's lost to the environment. I'm stating the obvious there because what most people are unaware of, the source of heat that causes heat stress, for example, during animal handling, transport and production, is actually the heat from the animal, not from the environment. What the environment does is impinges upon the efficiency of heat loss. And all the heat produced by the animal has to be lost by these various avenues. Avenues of evaporation, convection, radiation and conduction. And the environment changes the gradients for that potential heat exchange. So if the environment is hot, then there is less of a gradient for loss by convection and conduction. If you're in direct sunlight, there's potential for gain by radiation. If the humidity goes up, there's a reduced gradient for evaporative heat loss. So changes in heat loss, either increasing in cold or decreasing in heat, will have a potential effect on body temperature. So environmental factors that alter the gradients for heat loss will result in greater or lesser heat loads. Body temperature is actually heat production minus heat loss. And therefore, if these gradients change, we threaten homeothermy. That means there is a risk of altered body temperature, and the animal has to exhibit adaptive responses to increase or decrease heat loss. So what do we need to know in order to understand these processes? Well, we need to look at both behaviour and physiology, as described in the previous presentation. We can then model those responses and perhaps use the outputs of these models to develop strategies for design and control of the environment, of the animal situation, in order to optimise everything from its welfare to its health to productivity. I would emphasise that, as Marie stated, there's a hierarchical control. Given a chance, an animal will behave first before resorting to physiological adaptation. You get out of the heat or you get out of the cold if you've got a chance. Get into shade if it's sunny. Then it will resort to physiological responses. Now, all of these are part of homeostatic systems, the control of the internal environment. And there are two things we can measure to assess the efficacy of the response. Homeostatic success, how well does the animal control that variable? How well does it maintain its body temperature, its blood glucose, its partial pressure of oxygen in the arteries? How well does it control homeostatic success? but also how hard is it working? Is it panting? Is it sweating? Can we quantify that? Because that's homeostatic effort. And it's the balance of those two that matters to the animal, and also that constitutes what we can model. I'm going to talk briefly about an example of this that involves the transportation of broiler chickens. I've chosen it because these chickens were transported in Canada when it was minus 35 degrees outside. You would think cold stress would be a risk. This is what happened inside the truck you just saw pictured. The truck is driving away from me, that's the front of the truck. There are some small air vents at the top. You can see on the temperature scale at the side, it was minus 35 outside. Look at the temperature towards the front upper part of that truck. We're now 90 minutes into a journey to the slaughterhouse. The temperature is plus 30 degrees. Birds were dying on that truck. Birds that were diagnosed at the plant as having died of cold stress because the dead bodies froze to the crates during storage and layerage. Why is that important? Well, because it illustrates extremely well the problem. That environment was modified by the heat and moisture production of the chickens until it became lethal. And that was because it wasn't properly ventilated. We might return to that. So how do we model the situation? Well, let's look at an environmental stressor, let's quantify it, and impose it upon an animal. Then measure selected responses that truly reflect homeostatic effort and homeostatic success. Then, let's look at how the behaviour and physiological variables change in relation to thresholds that might constitute a threat to the animal's well-being. We can actually start to look at different thresholds, different amounts of stress that are acceptable for different stimuli and different responses. We can combine all of those into a theoretical model. And here is such a theoretical model where we look at a physiological response against a measure of imposed stress. Mild stress might be considered to be where there is little change in the controlled variable we're interested in. Moderate stress, when change starts to accelerate. Severe stress, catastrophic failure of adaptive homeostatic control. In other words, leading eventually to mortality. In order to do that, for thermal stress, we need a quantified measure of the stress. For thermal stress, it has to include temperature and humidity. We need a single integrated index. And we, in fact, developed one called apparent equivalent temperature, derived from absolute temperature and a measure of water vapor pressure or water content. Here you see that variable plotted, apparent equivalent temperature, against change in body temperature for broiler chickens in transport crates. And even the most cynical members of the audience will agree that that real data model is remarkably similar to that theoretical model. So you can take the values for temperature and humidity that gave rise to those apparent equivalent temperatures, and you can plot them usefully for the industry. You can say what temperature humidity combinations are safe, constitute alert or danger. So you've got a physiological response model that can actually be used. And that model is used, it's used by the poultry industry, it appears in the Abbey Gen Ross manual, and it's used in legislation by the European Union. Where does it take us? Well, it means that on the basis of those models, we can actually design, in this case vehicles, but it could also apply to housing, systems for rearing animals. The modelling approach can be successfully applied to many, many situations to reduce discomfort. In the case of vehicle design, there are already vehicles out there that have some form of environmental control. There are new vehicles that actually have air conditioning. And many of you in the audience will be aware that the requirement for mechanical ventilation is mandatory for long journeys over 8 hours for red meat species as laid down in 1/2005, the transport regulation. We're now involved in new projects looking at the design of vehicles for tomorrow. And that same technology, that same modelling approach can be applied to animal housing and many, many other situations. So what I would say in closing is quantitative modelling provides the basis of understanding the impact and consequences of environmental stressors, not just thermal stressors but many others as well, that can cause discomfort. That in turn facilitates the development of real practical solutions, real world solutions, and methods that allow us to reduce discomfort resulting from thermal stress in production systems during handling, and as you've just heard in detail, during transport. Thank you for your attention.
Thanks, Malcolm. So we're now moving on to the third in this pair of talks. To look at the other part of discomfort, from thermal comfort to physical comfort, with Fritha.
Thanks very much. Hopefully you can hear me at the back. So today I'm going to be talking to you about lying and resting areas and the comforts that they might give to an animal, and I'm going to be focusing on dairy cattle. A lot of people think that our zero grazing, so an environment where we take the cow away from a field, is a very modern phenomenon. But actually it's not been. It's been something that's been around for a very long time. We've kept cows near to where we've lived for a long time, and we've also kept cows within cities. So these are now pubs. Well, this one's a pub, I think, and this one's a chemist in London, which is where we used to keep cows in the middle of the city. So zero grazing isn't something that we've only just started to do. However, in most modern systems around the world, you'll see something along these lines where you've got a bedded area indoors for cows to lie down. These ones are free stalls or cubicles, and the cows may go out for a certain period of time in the day or in the summer, or a set period of time where the cows can go and graze. We've done some research fairly recently about the UK situation, and we know that there's about 100 or so farms in the UK that are completely zero grazing, where cows are housed all the time. But we also know that there's quite a lot of cows on farms where farmers do put their cows out to grass, which will house their cows for some of the time. So perhaps cows that are yielding at the maximum point during the summer, when most of the cows would be out, those cows might be housed all year. So there's a certain amount of, a higher percentage of cows that are housed all year round as compared to farms that do so. Now, why is this important? Well, it's important because lying down and comfortable bedded areas is very, very important for dairy cattle. They do it a lot, and a healthy cow can lie for upwards of 10 hours a day. It's very, very good for milk production. So we know that cows that are lying down for longer periods of time during the day produce more milk. There is a bit of a problem. It is a little bit confusing because a cow that is in pain in its feet will also lie down for longer bouts in the day, which you can see on this wee graph here. So we've got the proportion of cows lying down in a group, and then we've got proportion of cows that are scored lame, and you can see that there's a weak correlation there. So it's always difficult to know exactly why a cow is lying down, but we would like to separate out the healthy lying from those that are in pain. But today we're just mostly interested in normal lying behaviour. Unfortunately, you can find very uncomfortable housing in farming systems, and these are all pictures taken on UK farms where you've got poor quality bedded areas where cows can't properly fit into them. So this cow at the top right is struggling to fit into a very small cubicle, and she's sort of hanging over the edge, and as is this one here, and that they can't really get comfortable rest. I think we would all agree in those type of circumstances. When we have poor quality housing, we get increasing problems with cows' legs. This is relatively normal, sadly, to see on farms where cows are housed in cubicle bedding, where the hair gets rubbed away from the edge of the hock. But it can lead in extreme cases to very large swellings or large injuries, which of course is going to cause pain and injury, which is a different freedom. So I won't go on to that just now. But what we want to say is that it is possible to provide nice, comfortable bedding for cows in modern housing systems, and the majority of farmers do provide something that is comfortable for cows to lie down. And it's the correct size and it's nice and clean, and the cows go and lie down for the right amount of time. The great thing about cubicles as a way of providing lying surfaces is that they are clean. So they reduce mastitis as compared to open areas in sheds, sort of straw areas. And they're also very cheap. So once you've put them in, they're cheap to maintain, which is fantastic. There's been tons of research. You can look at loads of research out there on the size and the shape of the cubicle. So we might look at the height and the width and the length of the cubicle to fit the cow. And we might also look at the types of bedding used on top of the cubicle to make sure that it's dry and not wet, and that it's the right material that doesn't cause rubbing for the cow's legs. Well, that's great, but do we really think that cubicles are the things that cows want to lie down in? So this is a picture of cows in a field, obviously, and what you'll notice is that they're not all lying down in a line in the way that you've seen in the cubicle housing. They're also choosing to lie in different spaces from one another. So some of them are lying very close to one another, and then some of them are much more spaced out. So they don't all lie in a line, they don't all lie down facing one another, and also they choose different postures to lie down in. So what we wanted to know was if the type of cow housing that the cows were in affected whether they wanted to go and use a field as a loafing area or somewhere to be during the day. So a loafing area is somewhere where you'd expect the cows to all be standing up, but we had an inkling that cows actually might like to lie down in it. Also, we wanted to know if the types of behaviours seen within this field area would be different depending on what type of housing the cows had been housed in, and also how motivated the cows were to go into the field type area when they were housed in different housing. So we carried out an experiment, as Maria's already introduced, where we had groups of cows, and they were either housed in cubicles or they were housed in an open straw area. So the open straw area allows for similar types of lying down as a field would do, in as much as the cows can choose which way they space out. They can also choose different posture, and of course the surface is also maybe a little bit springier compared to cubicles. So these two different areas, and cows in one group would be in the cubicles first for a period of time, and then they would go into the straw for a period of time, and vice versa. And we had a loafing area which was a field, so it was a small field which wasn't there to provide grazing, so we'd taken out most of the grass. It's been cut very low, so it was there just as an area to exercise in or to lie down in. And we measured lots of stuff. So we had a baseline period where they were only in the house, and a preference period where they had preference to choose to go into the field if they wanted to. And we measured behaviour, we measured lying times, we put sensors on the animals. We also measured things about the weather and the ground conditions. We also were particularly interested in the lying postures, because there are postures like this one which can't really happen in many cubicles because the cubicle design doesn't allow for it. So some results. What we can see here is that cows that were housed in cubicles, remember they saw both housing types, but cows when they were housed in cubicles spent an awful lot more time outside. The pale grey lines are out compared to the dark grey lines. So they spent more time outside in the field than those housed in straw. So the cows housed in straw spent roughly 50% of their time inside or out. So that shows you that the cows housed in cubicles were more motivated to spend time outside, at least in terms of their preference. When we gave the cows access to the fields, the cows that were housed in straw, which I've called straw cows, which they weren't really, they were actual cows, but they lay down at night in the straw, and they fed during the day, so they ate their total mixed ration in the daytime. The cows that were housed in the cubicles fed at night, so they stood up and fed at night to their total mixed ration, and they went and lay down in the field during the day. So the cows rearranged their time in order to rest somewhere more comfortably. They were also spaced out in a slightly different way. Of course, we had an experimental setup, so the cubicles, there weren't very many choices of cubicles to lie down in, so if they wanted to space out and be away from their next door neighbours, then they couldn't really do that in the cubicles. Why might this be the case? Well, of course, the lying surface is different, and the postures that they're able to perform are also different out in the field as compared to in the cubicles. What we're wondering is whether cows might get a better level of rest and sleep out in a place where they can perform these different postures. So again, these postures you can see in the straw, and this is the only way cows can sleep in the cubicles. So perhaps they're getting a better level of sleep outside. So this is something that we're going on to research now, so please do watch this space. But just really I want to conclude that when we are housing animals either more constantly or all the time, that we need to make sure that we're providing good quality bedding and the best that we can, preferably from the cow's point of view and not from the human's point of view. At least if you can do that in a way that doesn't cost too much money and doesn't affect in terms of cleanliness as well with the hygiene benefits of cubicles. We also need to understand what an animal needs to feel comfortable, and it might not just be a little bit of extra sawdust within the cubicles, for example. And that the science that we're doing, the animal welfare science, allows us to understand the priorities animals have for all these different types of behaviours. And that's all I'll say just now. If you want to ask me more questions, I'll be around all at lunchtime.
Thank you very much. Are there any burning questions for any of our speakers on the second freedom? Question here?
It's all right, you need to worry about it.
You're going to shout.
From your line point of view, you said you recorded the weather. Did the effect of rain alter the cow's ability to stay in the field and lie down, or come in and lie down?
Yeah, absolutely. So the experiment I've just shown you there happened to be mostly quite nice weather. A previous experiment which we'd done, the photos that Marie showed at the very beginning, was very heavily affected by weather. We had a poor year that year. And when the ground was wet, the cows still went outside, but they didn't lie down. When it was actually raining, the cows stayed inside or went into a roofed concrete loafing area. So they still had a motivation to go outside when it wasn't raining, but when the ground was really wet, and I'm saying it was just, well, we thought ducks would move in soon, it was very wet indeed, and then the cows didn't lie down outside. So they would rearrange their priorities. The cubicles were nicer than the wet puddles outside, thank you very much, in that case.
Yeah. Okay.
I don't know if you measured this, but did you see an increase in milk production for the cows that were getting a better, comfortable sleeping areas?
Sadly, it was too short a period of time to really see that. We saw an inkling that that was happening, but not really enough time to be able to measure that properly. So we'd have to do it over a prolonged period of time.
Anything else? As I said, they will be around, so you can ask those questions later. Now, we were a little bit concerned about your own comfort. And I don't want to contravene your second freedom. So we will have a very short break, just 10 minutes or so, because we are running a little bit behind due to my poor chairing. So if you want to get up and stretch, deal with any other comforts, but please, can we start again at 20 to 12? Thank you. Very good, folks, kept time. Is it working? You have to hold this. That one's just got a flick. It's got light.
The second mic we can actually hear. It wasn't as, yeah, we could. I mean, it was okay, it wasn't great, but it's not as clear as these ones down here.
I don't know whether they need it for the recording or not.
Did IT put any battery in it anyway?
Well,
It's not on there, thank you.
Just play it again.
Good.
You can
Yeah, I want to take it all the way. Right, very good.
so Eddie's got a really
I put the spanner in the works. I just need to change one of these, so I put seconds instead of minutes. Okay. How do you actually, can you get into the thing just to change one word on one side?
see Simon's adding spanners as well.
move on to the third freedom, that's freedom from pain, injury and disease. And our speaker is Dr. Kenny Rutherford from SRUC.
Okay, thank you, Kathy. So what I'm going to take a few moments to do now is really just discuss a little bit about pain as an aspect of one of the 5 freedoms. I'll really start off with a very basic consideration of what pain is, then discuss maybe why pain could be bad for welfare, particularly some of the less obvious reasons why it might be bad, and that will include a brief discussion of why pain is bad, full stop. And then at the end I'll say a little bit about assessing pain in animals. So pain is a component, along with injury and disease, of the third freedom. It's interesting to note actually the very first version of the 5 freedoms that Falk produced in 1979 didn't mention pain at all. That came along later, but now it's considered a really critical component of animal welfare science. So what is pain? Well, pain is a term that we're all very familiar with. We use it regularly in our day-to-day lives. But the moment you start to delve into it, you really see there's a lot of really intense scientific and philosophical discussion about what the term pain means, how we should understand it. The International Association for the Study of Pain defines pain in this way: an unpleasant sensory and emotional experience associated with actual or potential tissue damage. And what this definition has in common with a lot of other definitions that people have put forward is that it's clearly the case that it's being acknowledged that there are 2 different components to what we consider pain. There's a sensory component and there's an emotional component. In fact, in human considerations and definitions, people sometimes add a third cognitive component to that. But these 2 components are very important, and they maybe have different implications for welfare. The sensory component is really what we perceive about the location, the intensity and the type of a challenge to our body. And the brain integrates this sensory information picked up from receptors around the body. It takes information from previous experience, from the environmental context the animal is in, and from information about the animal's own internal body state. It integrates all of that information and produces the emotional reaction, which is what we understand as pain, the hurt, the unpleasant aversive state. Now, the modern consideration of what pain really is pain is a motivational state. It's an evolved solution that allows individuals to limit harm to their own body. And it alters behaviour as a consequence of this motivational urge and imperative. The behaviour is altered to limit tissue damage, to withdraw from a source of harm, to avoid it, in the longer term to promote recovery, and finally to avoid reoccurrence of the negative state that caused the pain in the first place. And one of the implications of this view of pain as a motivational state in the animal is really that pain therefore has to compete with other motivational states for final control over the animal's behaviour, the output of what the animal actually does. One of the implications of this is that pain overrides other behavioural states. We're quite familiar with that. But the less obvious implication is actually that pain can also be overridden by other motivations where higher priorities exist. And this competition between pain and other motivational states is really the reason why pain assessment in animals is difficult. Because a standard injury, a standard level of disease challenge will produce very different pain experiences in 2 different people, in 2 different pigs for that matter. So I said I wanted to just really address the issue of why is pain bad? Why does it actually hurt us? Why does the system to protect our body need to hurt us? And I think a really interesting example comes from the work of this gentleman, Paul Brand. He was a surgeon who worked with leprosy patients around the world. And the reason we know that pain is bad is because when it's not bad, it doesn't work. It doesn't protect our body. And this is quite clearly shown from the work that Brand did. So leprosy is an interesting disease because it causes reduced pain perception. The bacilli attack nerves and fingers and feet, meaning that people no longer perceive injury and they have horrific injuries. They lose fingers, they lose toes and so on. So Brand wanted to actually replace this lost protective system with an artificial device. So he had these sort of systems in gloves or socks with sensors on them to try and replace the pain system and provide this protection for people. So after 5 years of study and millions of pounds of research grants, this system basically failed. And it failed for the reason that people, when they were given the option, just turned it off if it hurt them. So it no longer had that protective function. And Avray, in a recent paper discussing this motivational behavioural perspective on pain, said, merely providing information about actual or even potential body damage does not suffice to elicit genuine pain. Though there is a perceptual aspect to pain, this perceptual aspect has to come with a motivational force as well. And this motivational force has to be beyond the control of the organism feeling the pain. And we see other, sometimes horrific examples of the importance of pain in people who, through genetic mutations or through brain injuries, are either completely insensitive to pain, or perhaps even more weirdly, have this odd situation where they have the sensory component of pain, but not the emotional component, a condition called pain asymbolia. And these people, no matter how careful, alert, smart they are, commonly injure themselves, and they very often die young. So pain clearly is incredibly useful. As the Cambridge ethologist W.H. Thorpe noted in his appendix to the Brambell Report, pain is a sensation of clear-cut biological usefulness. So it's important to note in terms of the 5 freedoms that actually taken literally, freedom from pain for animals as for humans would be disastrous for welfare. We do need some functioning pain systems. Why then do we care about pain within animal welfare? Well, there is the most obvious thing. It hurts. It's unpleasant, it's aversive. Very often that's a result of things that people have done to animals for our own benefit. And very often in the captive situation, those benefits that I mentioned of changes to behaviour no longer function. And in fact, there's also issues that the experience of pain, if untreated, can lead to alterations in future pain processing or chronic pathological pain states. But there are a whole host of other reasons, some of them less obvious, as to why pain might be bad for welfare. It disrupts behaviours like sleep. It disrupts sleep patterns. Also other behaviours, feeding, drinking, maintenance behaviours such as grooming, are negatively affected by pain. And perhaps less obviously, there are issues with what pain researchers sometimes called extended pain emotions. So we now know that increased fear or anxiety is an inherent component of pain states for animals as it is for humans. And indeed, anxiety and depression disorders are a common comorbidity with pain in the human population. And perhaps one of the really interesting areas of research that's emerged in the last few years is the role of pain in social interactions. So we now know that pain behaviour can act as a signal or as a cue to other individuals. So for instance, it can act as a signal, perhaps to elicit help from other individuals in the environment, perhaps causing some sort of empathetic response in those individuals. The most obvious example of that might be mother-offspring interactions. But we also know that animals can use pain behaviour in others as a cue to guide their own responses. So we see studies showing that a rat which witnesses another rat experiencing pain will in the future show an exacerbated pain response itself. And more generally, animals witnessing other animals in pain increase their own fear level. And finally, pain may cause aggression. So one of the most familiar examples of this is in behavioural clinics, where pain is found to be one of the most common underlying causes of dogs that are presented with abnormal levels of aggression. Pain also can have negative impacts on other aspects of physical and physiological function. Pain is a stressor that can have negative downstream impacts in the body. It can impair gut function, lung function, cardiovascular function, and impair immune function. And the most obvious area where these are a concern is an area that the next speaker, Eddie Clutton, is much more familiar with, is in post-surgical situations where alleviating pain is widely recognised to be important for promoting good recovery in humans and in animals. Pain also has this memory function, so we use pain to guide our future behaviour, and this can mean that animals can make incorrect or correct but unhelpful associations between people or places and things that have caused them pain previously. So the most obvious example of this is a dog that doesn't want to go to the vets, but farm animals show these associations as well, and that can have implications for their own welfare, but also for the ease and safety with which they're handled. Yet despite all this evidence that pain is really bad for animal welfare and can actually be bad for animal production in farm animals, pain very often goes untreated. So these are just some data from a survey of 1,500 farmers that we did a couple of years ago, where we included a question about how often lameness was treated with pain relief in these different livestock groups. And I've added at the end there just an indication of the UK national prevalence for lameness in these groups. So we can see, for instance, in ewes there, the national prevalence of lameness is thought to be about 10%, but around 63% of farmers never provide pain relief for that. Finally, assessing animal pain is obviously the area that we're concerned with in animal welfare, and we need to assess animal pain in three main contexts. In a veterinary context, in the clinic, or in a laboratory context as part of routine animal care. We also are involved in a lot of animal pain assessment in the sort of work that we would do here, which is work that's aimed to assess pain for the benefit of other animals, for developing treatments or drugs. And finally, the vast majority of pain research in animals is in biomedical research with the aim to improve drugs and treatments for humans. And it's important to note that what's the appropriate method for pain assessment in these different contexts varies greatly. So in a clinical context, we need cheap, quick methods that provide an immediate answer, whereas in the other contexts, we can have more expensive, lengthy methods that are perhaps retrospective in nature. But I think it's really interesting to note that actually the biomedical world is where people are increasingly turning to this motivational behavioural perspective on pain to develop new methods for assessing what pain really means to animals, so the importance that it has in their life. And this is actually because there's a widespread concern in the biomedical world that previous pain models were really bad because they didn't address that key aspect, the hurt, how much it really means to the animals. And they want to develop drugs that alleviate that in humans. That's what really matters to humans. And I think we perhaps need to learn from that in the sort of veterinary welfare research world, that we can perhaps ironically learn something from the consideration that the lab researchers are giving to that aspect of pain. So finally, to conclude, pain is a really complex topic. It's perhaps more complex than we readily appreciate in our day-to-day life, but it is central to animal welfare. It has key and really often severe impacts on the affected individual, and we're increasingly realising that it can have effects on other individuals in the surrounding area too. And there are some key questions that remain. Fundamentally, how do we assess this issue of what pain actually means to animals, the value that they might place on having that pain alleviated? There are still questions actually about which animals have pain. There's really intense widespread discussion about different groups, about fish. Do fish feel pain? About crustaceans, there's a lot of work in that area. So there's still questions about where we draw the line between animals that have some morally, ethically significant pain and those which don't. And finally, one of the key issues that we need to understand more to address that issue of why pain goes untreated is really understanding the societal, the economic context within animals in our care. So with that, I'll say thank you very much and hand you over to our next speaker, Professor Eddie Clutton.
Right. I've got this. Okay. Right. Thank you very much, Kenny. I must admit, I feel a little bit fraudulent here because I'm not an agriculturalist nor a welfarist. My interest is in the welfare and pain management in production animals, pigs and sheep, in the biomedical research environment. So contemplating this last night, I thought, I'm not an adherent to the 5 Fs, I'm more an adherent to the 3 Rs, a doctrine proposed by Russell and Birch in 1959, which replaces, reduces and refines animal welfare for those animals in biomedical research. So I was watching Only Connect at this time and I thought, 5 Fs, 3 Rs, I'm a 4L person. what I want to do this morning is simply cover the massive amount of neurophysiology information which has been accrued since the 1960s and the parallel developments in pharmacology to discuss how, in fact, it is quite possible to control most aspects of animal pain, certainly in the biomedical and the veterinary environment, perhaps not for a variety of reasons I'll finally discuss in the agricultural sector. We've known for a very long time, and Ken's already intimated, that under certain motivational states, animals are capable of performing activities which intuitively would not be appropriate in the presence of severe pain. And of course, this applies to people on the rugby pitch and the battlefield too. And that's been known for a very long time, but it was only in 1973, with the simultaneous publication of 3 papers, that it was realized that there was an endogenous pain-relieving system inherent in vertebrates, in mammals, which controlled pain in the face of traumatic injury, including surgery itself. And in the face of severe injury, whether it be surgical or traumatic, if that pain is severe enough, it activates propiomyelinocortin, we've heard this previously, and this mediates the release of dynorphins and enkephalins and other mediators, endogenous opioids, which control the ascending pain pathway coming from the injured lesion. And if the pain is severe enough, then this downward suppression of the arising pain impulse can eliminate all sensation of pain. And what this did in 1973 and thereafter was explain why stress hyperalgesia was a real naturally occurring phenomenon. And of course its biologic significance is in the face of severe injury, an animal can go off and hide, take refuge and start to cure itself. It also explained the clinical activity of morphine and the opioid analgesic drugs which have been used and abused by humankind for at least 3,000 years. And importantly, it revealed the role of the spinal cord in pain modulation, particularly this site here, which has become the centre of more intense research since 1973. This part, arrowed here in yellow, is known as the substantia gelatinosa. It exists there, and it's been the seat and the site of major research into pain management ever since. Now, this is the pain suppression or modulation system. What has become increasingly of interest in neurophysiologists and pain clinicians is the opposite system, that which amplifies, augments the sensation of pain following traumatic injury or surgery. And this amplification comes in the general name of sensitization, and it has 2 components. One is peripheral, and it means that the site of injury becomes more painful if nothing is done about it. And the increased barrage of pain impulses ascending to the substantia gelatinosa, if uncontrolled, has a secondary effect known as central sensitization. And again, this follows changes in the substantia gelatinosa. Now, the importance of this is if the original injury in the peripheral site, whether it be traumatic, as I say, or surgical, under certain circumstances, that injury can heal itself. But, and neurophysiologists will hate me for saying this, a pain memory can form in the spinal cord or at the higher levels of the central nervous system, which creates an impression that the animal is feeling pain, even when there's no organic damage there. And this accounts for a lot of phenomena, such as post-traumatic surgical pain. After we've had major surgery, it still hurts for a long time afterwards, even though the surgeon is no longer within our innards or moving our chest apart. It also accounts for the fact of the phenomenon of hyperalgesia, which is where previously painful stimuli are now enhanced in the degree of pain generated by them and for a longer period. It also explains the phenomenon of allodynia, whereas previously a non-noxious stimulus, like a change in temperature or light touch or even modest movement of a previously non-painful site, now generates the perception of pain. This phenomenon of sensitization also explains secondary hyperalgesia, which is where the perceived area of painful tissue becomes much greater than that originally damaged. So the zones of affected skin around a thoracotomy incision, for example, becomes greater if sensitization is not controlled. And also this explains quite bizarre phenomena, neuropathic pain, which describes a situation where there's no tissue damage occurring, but the sensation of pain is still appreciated by the animal or the individual because of these pain memories set up at spinal and supraspinal centers. And understanding the whole process of central sensitization helps to explain and provides a rationale for effective analgesic therapies, which is now commonplace in veterinary anaesthetic practice, in the management of biomedical research, in the quest for refinement, but sadly not in the agricultural sector. There are 4 basic strategies which we now employ, given this understanding and the availability of new drugs, which can very effectively manage animal pain. And the first one is preemptive analgesia, and this basically means giving an analgesic before the insult is applied. And this has, of course, major implications for husbandry procedures such as castration or docking, because if we give analgesics before the pain is inflicted with the scalpel, then the fires of inflammation, peripheral sensitization generated by the surgical insult can be damped down before they're set up. And the process is quite straightforward. When tissue is damaged, cell membranes break down, release phospholipids. Under the action of the enzyme phospholipase A2, they produce arachidonic acid. These undergo a variety of changes to produce lipoxygenases and a whole range of chemicals, which, in combination with other factors released from damaged tissue, produce what's colloquially known as a sensitizing soup. And the sensitizing soup has various effects, but principally produces the signs of inflammation in damaged peripheral tissue. So we get blood vessel dilatation, redness, coagulation defects, and the ingress of leukocytes. But importantly, from the pain perspective, we get an alteration in the firing threshold of pain fibers. The threshold for firing is reduced, so they're more likely to fire in the presence of noxious stimulation. And the gain of the fibers is increased insofar that a standard stimulus will now produce a supramaximal response. So in other words, the pain message in the periphery is amplified in the presence of sensitization. And so the barrage of pain fibers to the CNS is accelerated. Now, these can be blocked most simply before the damage is done, before the piglet is castrated, by giving a non-steroidal anti-inflammatory drug such as flunixin, meloxicam, carprofen. That simply switches off cyclooxygenase 2, which is the enzyme responsible in part for generating the sensitizing soup. Steroidal drugs, dexamethasone, betamethasone, can also be given in this respect. And we can simply switch off the nerve fibers responding to the sensitizing soup by the application of local anesthetic. Widely available, been available since 1940, and very inexpensive. We can control central sensitization too by similar methods. When the pain afferents hit the substantia gelatinosa, a variety of changes occur, extremely complicated. As I say, been an area of great research interest over the last 50 years, and if you're interested, here is a suitable review article. What's important to note is that these changes in the spinal cord occur within seconds, minutes, hours, or days of the tissue being damaged, depending on the specific process we're looking at. And the net effect of these processes is basically to amplify the pain message. It's to make the animal hurt more than it normally would have done. These central processes differ from the peripheral processes in they co-adopt inputs which normally would not be regarded as painful, such as light touch. And eventually they're capable of spontaneous discharge. These nets or foci of neurons within the spinal cord generate spontaneous messages, almost like an epileptiform seizure, which creates to the recipient the sensation of pain, even though damage has ceased. As I say, then further centers higher up in the neuraxis can also form these spontaneously discharging foci, which create a pain memory, even when pain is no longer being inflicted. And a lot of the drugs that we've had available in veterinary practice for the last 100 years are very effective at preventing this sensitization occurring. Most importantly, appreciate this fact. If local anesthetics are used to block a nerve carrying pain fibers to the substantia gelatinosa are blocked with a local anesthetic, those pain impulses are not received and cannot cause these changes. So this was a hypothesis proposed back in the 1920s in human anesthesia by a chap named Kreil, that if you block or deafferent the animal, pain fibers cannot set up pain memories and the animal will be pain-free. If that's impossible because of the nature of the lesion, then there are a whole range of other drugs that we can apply, either systemically, injected into the bloodstream, or more commonly extradurally into the spinal space itself, will block these changes occurring. So some non-steroidals, all the opioid antagonists will do it, local anesthetics, alpha-2 agonists, xylazine, midatomidine, and most importantly, the NMDA antagonist. That's probably the most important class of drugs known for efficacy at blocking central sensitization. And we all know and we've all heard of ketamine, but this is an extremely important drug in blocking this proliferation of N-methyl D-aspartate receptors at this site as part of the central sensitization process. Nitrous oxide, also identified in 1820, I think, as an analgesic, is a very potent NMDA receptor antagonist. So that's the basic neurophysiology. We can, of course, control pain using high doses of analgesics. But the problem with this has led to this second strategy development known as polymodal pain therapy. If, for example, in a lame pig, we use a high dose of a single drug, such as non-steroidal, high dose flumixin, the problem with that is by using high doses, we get a high risk of side effects, renal damage, gastrointestinal ulceration, and blood dyscrasias, etc. Similarly, with ketamine, we'll get psychic effects of long duration, catatonic animals lying, salivating, possibly convulsing. And with opioids, of course, high doses will cause respiratory depression, possibly euphoria, dysphoria, and certainly adverse gastrointestinal effects. The strategy of polymodal pain therapy avoids the use of high doses of drugs, and recognizing that each pharmacologic class of drugs has different properties and acts at different levels of this ascending pain hierarchy, means we can use lower sub-analgesic almost doses of each pharmacologic class to produce the net effect of animal comfort and analgesia, but without the side effects associated with a single drug class. And that strategy goes by the name of polymodal or multimodal pain therapy. The third strategy, resulting from an understanding of sensitization, is misnamed. In the veterinary literature, it's given this name partial intravenous anesthesia, but it's not solidified, certainly not in the medical analgesic literature yet. But it raises the point that anesthesia, anesthetics per se, and that would include, for example, carbon dioxide used for castration of piglets in Europe, does provide analgesia for the duration that an anesthetic state is present, but it does not prevent sensitization either in the periphery or centrally. Now, what this means is no matter how our animal is anesthetized, when it recovers from its anesthetic, if there has been no blockade of the sensitization processes, when the animal recovers, it will feel the full pain of what was inflicted on it whilst it was unconscious. Now, many of the drugs that we have are available for use in sedating and blocking sensitization processes, also have central nervous effects almost akin to anesthesia itself. So morphine, for example, in high doses will produce conditions almost like anesthesia. Partial intravenous anesthesia capitalizes on this fact and uses relatively low doses of general anesthetics and high doses of these anti-sensitizing drugs to provide the majority of surgical conditions, but at the same time blocking peripheral and central sensitization processes. So the net result of this is if an animal is anesthetized with a relatively high amount of concentration of drugs preventing sensitization compared to the general anesthetic, which does not, then when this animal recovers, sensitization has been blocked and we have good surgical conditions with good postoperative analgesia. And finally, prolonged postoperative analgesia, something that's not considered is that the fires of inflammation may last longer than the duration of action of drugs given to suppress these processes. So we can give a non-steroidal anti-inflammatory, we can give local anesthetics before we do something to this animal, we can give a general anesthetic, we can insult it. Central peripheral sensitization doesn't occur. When the animal recovers, it's pain-free. But when these drugs wear off, if there is any residual inflammation damage at the surgical or the traumatic site, then the fires of inflammation will be set up again, and basically the stable door has been opened, the horse has got out, and the whole process has re-established itself. So we've gone through these processes of preemptive analgesia, polymodal pain therapy, for no purpose, and the animal feels pain and may well become sensitized. So the simple way to avoid this is, after insulting an animal, is to make sure that analgesics, particularly anti-inflammatory drugs, are given before all inflammation at the peripheral site subsides. And that may mean as long as 5 to 30 days with non-steroidal anti-inflammatories. To conclude then, in the veterinary sector, and certainly animals in biomedical research, it is almost entirely possible to control all animals' postoperative pain. It's as simple, it can be done. Unfortunately, in the agricultural sector, pharmacopolitics make this unlikely. The principal problem, of course, is drugs in the food chain. It's impractical because the best techniques require training and require time to do. And of course there's cost, and the cost is principally lying with the staff rather than the drugs themselves. So I've already indicated, most of the useful drugs in the prevention of desensitization have been around for a very long time, local anesthetics, morphine, and they're therefore very inexpensive. Thank you very much.
Thanks very much. So our last two speakers are a really fascinating pair of talk. I'm afraid in interest of staying even vaguely within shouting distance of our programme, I'm not going to have any questions, but do please speak to either Kenny or Eddie over lunch. We've got a long lunch break, plenty of time to do that. So we're going to move on now to our fourth freedom. This is the freedom to express normal behaviour, and I'm going to pass on our first speaker in the pair of talks will be Professor Françoise Wimmelsfelder.
Good afternoon, thank you very much. In this session, my colleague Emma Baxter and I will be talking, as Kathy said, about the fourth freedom, the freedom to express normal behaviour, which was defined by Falk as the right of animals to experience that freedom by providing sufficient space, proper facilities, and company of the animal's own kind. And it's interesting, and this freedom stands out a little bit from the others, in that it's the only freedom to. All the other freedoms are freedoms from, things that we should protect the animals from or that they should try and avoid. But this is more of an invitation to the animals to be active, to engage with their environment and to express themselves. And indeed, since the formulation of that freedom to express normal behaviour, there has been plenty of research in the following decades that demonstrates that actually being active matters to animals. It is important to their welfare. It is not enough for animal welfare to provide animals with the functional endpoint or the functional outcome of their behaviour, such as, for example, nests or food or appropriate heat, temperature. In fact, animals want to be active in achieving those goals. They want to make decisions and develop and achieve those outcomes through their own competent activity. And there is not the time, of course, now to actually go into more detail in this research, but there are published papers showing that if you give animals, that poultry, for example, will continue to build nests even if you put a ready-made nest right in front of them. And the same is true for food. Animals will continue to show food searching activity or to work for food by solving problems or puzzles, even when desirable food is placed right in front of them, which they could obtain without any effort whatsoever. And also, when animals have a chance, they like to go looking around for new things to do. They will explore their environment, pay attention to it, and engage with it, apparently for the sake of that engagement itself. And particularly well known as an example of a behaviour that seems to be a goal in its own right is, of course, play. To this day, it's been really difficult to find out what the functional endpoint of play is, but surely it seems to be fun, and animals like doing it, as of course they also like engaging in social interaction for its own sake. And I want to briefly honour here, since we're putting things in historical perspective, the pioneering role in this sort of research that was played by the late Professor David Woodcock, who was Professor of Animal Welfare at our institute in the 70s and 80s. And he was a pioneer in starting to investigate phenomena like curiosity and play and natural competence in farm animals, particularly pigs. And he demonstrated very clearly that these sort of traits have not been bred out of animals by domestication. The famous Edinburgh pig park, where pigs were given space, plenty of space and materials to express normal behaviour, made it very clear that these animals still had all the capacity to build very complex nests, even though they hadn't had any experience of that beforehand. So the freedom to express normal behaviour is also very much still a present capacity to express normal behaviour. And David Woodcock also was one of the first pioneers in pointing out that if animals can't engage in this in expressing their behaviour. This is not a neutral thing, but in fact this may lead to forms of suffering, such as from boredom and long-term depression. And the more and more this research in recent decades into animal behaviour and engagement with the environment developed, the more it became evident that being active not only matters, but is in fact an intelligent process. It is not, as in the behaviourist times scientists used to assume, a matter of blind programming or blind instinct. Very much animals are intelligently engaged with their environment, and that is true right throughout the animal kingdom, not just for very complex mammals. Increasingly sophisticated tests in fields like animal cognition research are showing now that the complexity and depth in how animals pay attention to their environment, they can remember things for much longer periods than we originally assumed. They are capable to express preference in complex ways, solve problems, think, plan ahead, make decisions, the list goes on. The more we start looking, the more we find that behaviours previously assumed to be instinctive are in fact expressions of intelligent engagement. So one way of summing up this increasing becoming clearer of how animals actually express normal behavior is that animals, should be said, they have a point of view. They're not just moving around blithely, and they can and want to actively give shape to their own life. In short, and this will be a concept that you're all familiar with, a way of summarizing all of this is to say animals are sentient beings. And this is now recognized in European law and very much a foundation for animal welfare science as well. And I'd like to emphasize how much the concept of sentience is leading to a change of landscape, so to speak, in the way we think about animals. Farm animals are no longer just seen as biological systems, but also as aware, sensitive, fellow living beings. And it's not surprising, therefore, I think, that there has been an explosion of interest in human-animal relationships, not only in animal welfare science, but in the social sciences and humanities disciplines like anthropology and philosophy. But in animal welfare science, there has the effect of the concept of sentience has been an explosion of interest in positive welfare, positive experience of animals. We don't no longer say animals have needs, but we are asking, how would animals actually like to live? What do they prefer? As this quote indicates from Yeats and Mayne, what use is there in satisfying an animal's vital needs if the life the animal then lives is devoid of any enjoyment? And as I'm sure most of you are aware as well, the Farm Animal Welfare Council published an important report in 2009 emphasising that we mustn't just provide animals with a life worth living, we must endeavour to give them a good life. So in a way you could say maybe Falk has re-articulated the fourth freedom here, saying yes, there's a freedom to express normal behaviour, but really maybe we should interpret that as a freedom to have a good life. And so indeed in recent times this theme has been taken up in numerous ways. Of course, first of all in science, and these are just the first pages of 3 recent reviews, scientific reviews of the concept of positive welfare, asking how should we understand feeling good in animals in a scientific way? How can we measure it? How should we understand positive emotions in animals like pleasure, comfort and joy? But not only is it a matter of science, as David Fraser pointed out in a recent article, where he says, the science we do to assess animal welfare is influenced by value-based ideas about what is important for animals to have a good life. And so this quote here is just an example of this is a paper by a philosopher about animal welfare, where he says, to flourish in its natural life is only achievable in a life that has choices, since the animal is a being whose nature it is to choose. Only then can it have its own life. So clearly here it is formulated as a first principle, a value that may lead to other measurements, but that in itself is a value that underlies animal welfare science. And so it seems to me that as we progress, placing more and more emphasis on concepts like sentience and positive welfare, there really is now a growing need for cross-disciplinary inquiry into and a collaboration between natural and social scientists and also academics in the humanities like anthropologists, philosophers and literary scholars. And finally, a third theme here maybe that is also a theme of communication. We can ask questions of science, questions of values, but there's clearly also a need to actually engage in communication with animals and try and see if we can try and learn how they are experiencing their life and their environment. And one way of doing that, not the only way, but one way is one example is a methodology we've been developing here at SRUC called qualitative behavior assessment, which is based on the idea that given that we regard animals as intelligent, sensitive beings, it follows that their behavior, again, is not just physical, but has an expressive, sensitive quality that maybe we can understand as a body language. Animals can behave in a way that is relaxed and playful and sociable, or by contrast we can investigate if their behavior is performed in a manner that is tense and stressed and perhaps listless or lethargic. So we can learn to perceive and judge such expressive qualities of the animal's demeanour to gain a better idea of how their interaction with the environment is affecting their quality of life. And we can ask questions like, to address their quality of life, are the animals behaving in a way that is engaged, relaxed and content, that is an expression of a good quality of life, or are they not? And before I have my final concluding slide, I would just like you to show 30 seconds of video of, I'm not a poultry expert, but this is a video clip of a chicken that I made that I think is quite a good approximation of leading a good life and the freedom to express normal behavior. And this was made in a local organic farm that's not too far away from here, where the situation is that literally the poultry, the chickens there's no fencing or no wiring limiting their freedom. They can go anywhere they want. And there's mostly huge fields, but there's also quite a large wood at the back of those fields. And one day when I was there filming, I found this chicken hundreds of meters away from its mates in the field, on its own in the woods. And I'd like to emphasize, when you look at this clip, that I did not use zoom. I was standing right next to this chicken filming it, and it couldn't have cared less. It paid me absolutely no attention. Well, the clip goes on for a while and it's lovely to look at, but in the interest of time, I think I'll go on. So that's presumably very nice. It's good from the animal's point of view, and it's very important to the animals to talk about what it means to have a good life from their point of view. But there is, of course, also there are other points of view, and I have no doubt that the livestock industry will be asking itself, how free is enough freedom? we, as one person once said, a producer once said to me, we're a business, we're not a luxury holiday camp for animals. But I'd like to just briefly point out as a conclusion that I think it's important to realise we can't undo the shift that has happened in our field in recognising animals as sentient beings. We have to move forward and accommodate this principle. We have to find ways to provide more meaningful activity to animals and more meaningful enjoyment and comfort. And of course, the primary question is, if we give animals more freedom to behave, more freedom of expression, how does this affect the other freedoms? Because there may be a payoff. It may be that more freedom to behave may also lead to more moments of fear and distress or even pain, for example, due to weather or illness. And we'll have to think carefully about how to balance and weigh up these different interests. And as I've said, I think it is clear that these sort of questions about what constitutes a good life should include quantitative assessments, qualitative assessments across a variety of academic disciplines. And then we can maybe address these questions in as holistic a way as we hope. But finally, of course, it is, if we are ever to achieve change on the ground, it is extremely important to collaborate with stakeholders and industry stakeholders and to engage in practical collaborative projects. And so that is my clue to introduce Emma Baxter and her talk, and she is somebody who has large experience in working with industry and policy in a practical context of trying to change animal welfare for the better. So.
Okay. Thanks, Francois. Hopefully you can all hear me. I think I might have the loud microphone. So as Francois says, I may be bringing this back down to earth a little bit by talking about some of the practical issues with providing for the fourth freedom. And whilst I will elaborate on a lot of the animal welfare science out there that has provided information about the importance of the behavioural freedom, I'll also talk a lot about the challenges that we face providing it. And the first thing to point out is that behavioural expression cannot be independent of the farming system that the animals are in. The animals are the primary users of the environment. They occupy the space 100% of the time, but they're not the only users. We've also got the farmers. They have their own needs that we need to consider. And then we have various parties throughout the supply chain that all have their needs and requirements, not least culminating in the consumer, who may well have animal welfare on their list of priorities, but it may not be top of the list, and it probably won't be in isolation from the others. So if you can keep in mind this picture as we go through the talk, and how important it is to think about how we might be able to facilitate behavioural expression in livestock systems. The wording of this freedom is quite tricky. It almost implies a limitless expression of behaviour as long as it's normal or natural. But what is normal for a domesticated livestock species? Do they still perform the full behavioural repertoire that their wild ancestors would do? And if they do that, do all of the behaviours actually need to be performed? Is it important for welfare for all of them to be performed? And I'll talk about behavioural need the whole way through, and obviously some of my colleagues have already mentioned it, but it's good to have a bit of a working definition as I go through, and this one by Jensen and Totes is very useful. It describes a behavioural need as the need to perform a specific behaviour pattern, whatever the environment, and even if the physiological needs which the behaviour serves are fulfilled in other ways. I'll use examples from the pig and poultry sector, partly because in these industries we have quite potent examples of where the fourth freedom was or is compromised. So these are the sectors where there's quite a lot of confinement systems, battery cages for hens, these are pregnancy stalls for sows, and this is a maternity unit for pigs, the farrowing crate. But the other reason for using these sectors is because they are where we have seen really good interaction between public opinion, policy decisions to then commission scientific research, and where we've seen fundamental change in legislation as well as fundamental change in systems So obviously the battery cage is banned in 1999 from Europe. The stall is partially banned in Europe, completely banned in the UK. And the industry is actively engaging in moving away from confinement systems in the farrowing house. So what about the evidence base that has led to some of these changes? Well, first of all, it's important to demonstrate behavioural need by identifying motivated behaviours that are performed in any environment. We've mentioned dust bathing before, so sham dust bathing occurs in environments where the animal has no substrate, so it's often observed in wire flooring. Francois mentioned David Woodgush and all of his work in the Edinburgh Pig Park, showing the importance, showing animals nest building, and we have an awful lot of research on that. And we have a lot of research showing that even in confinement systems, animals will try to perform nest building behaviour, so it's a highly motivated and driven behavioural need. Another tool is to see, for demonstrating behavioural need, is to see what happens if that behaviour is thwarted or prevented. And if we stick with nest building, there's a nice piece of research came from the group here, Alistair Lawrence and Susan Jarvis. It was a while ago, but it's still incredibly relevant. It was very thorough, and it compared sows that were housed in farrowing crates with those that were housed in a loose pen with substrate. And it took behavioural and physiological information to see the differences in the stress physiology of animals during their nest building period and during their farrowing period. And what this graph shows you is that the animals that were housed in the farrowing crate had increased cortisol levels, particularly at the peak time of nest building, compared to those housed in the loose environment. So therefore demonstrating a negative state for those animals. If you want to learn more about cortisol, I'll just plug our laboratory demonstration at lunchtime. But using the physiology of the behaviour, we were able to demonstrate that there was increased behavioural frustration in the crated animals as a result of the inability to fully perform nest building behaviour. It's also important to mention that the negative state is not just confined to the animal there. It can have a knock-on effect for their offspring. So behavioural frustration, animals kept in farrowing crates, they often go on to savage their piglets, so they show poor maternal behaviours. They may carry on trying to nest build into the farrowing period when they're giving birth, and this can increase the risk of crushing. So there's a sort of sustained negative state, not just for the sow. But instead of completely focusing on the negatives, it's worth pointing out that if we can actually allow for the behavioural needs of our animals, this could be positive for all stakeholders involved. If nest building is satisfied, it's been demonstrated that you can get more positive maternal behaviours during the parturition and farrowing process. So we get more lateral lying. Here, the sow is much more somnolent, allowing safe udder access. There's recent evidence, physiological evidence, showing that sows that are allowed to nest build have increased oxytocin and prolactin levels, which then goes on to increase colostrum intake and affect piglet immunity and therefore affect piglet survival. So it's a win-win for both welfare and production. Other tools in our kind of behavioural toolbox, if you like, for demonstrating behavioural needs is to look at preference testing. I'm not going to go on about this because Fritha and Marie talked about dairy cows and their preference to have outdoor-indoor places. But they're still reasonably simplistic preference tests, and it's quite useful to look at behavioural priorities as well and ask what an animal might prioritise if given different choices. And this is where we take examples from consumer demand theory. Rick has already talked to you a bit about how hard an animal will work, a domestic hen will work to get a foraging space. And we want to find out how much it will pay to obtain a resource. So if we use a poultry example again, this is some work done by Cooper and Appleby back in the early noughties. And here we looked at the importance of a nest box for a domestic hen. So we had a setup here. There was a home pen with food, water and a perch, and then the hen was trained to push a door, a load-bearing door, to access a nest box, or indeed go the other way and get back to the home pen. The door was weighted and a load cell gave information about how hard the animal was willing to peck and push to access either the home pen or the nest box. And what they found was that the results were based very much on motivations and the time. So closer to the point of lay, the hens would work very hard, would push very hard to get to the nest box. Equally, after they've been confined in the nest box for a period of time, they would increase their effort to get back to their home pen and take on board food and water. And these sort of tests, although performed in the laboratory without the kind of different complexities that go on in the real world for a hen, are incredibly useful. They build up a list of the behavioural priorities that animals have, and this then leads to us making recommendations about how we might have systems change. And the evidence, the weight of evidence demonstrating animal needs is palpable in many of the species. And it has led to changes, for example, in battery cages. So we no longer, in the EU at least, can have barren battery cages. We can have furnished cages. There is a recognition that the sow does want space during farrowing and nest building and farrowing. But are these systems good enough? Is it good enough just to furnish a cage? Is it good enough just to open up a farrowing crate? Is this good enough for animal welfare? Well, there are alternatives out there. There are plenty of alternatives out there that we do use, and these alternatives do allow more free. So obviously the problem solved. We should just put animals in these environments. Well, no, and this has been mentioned before. There are welfare problems with many of the environments out there. There are trade-offs. So this is a multi-tier barn system for hens and free range, and it's been shown that mortality and bone fractures are more prevalent in these systems. This is partly the fault, if you like, of genetic selection strategies to push for high-yielding animals. So our domestic hens are quite fragile beings. They can break their keel bone quite easily. So there are inherent risks in these environments, as well as other risks, obviously, in barren environments. If we let pregnant sows just let them out of stalls without any thought about the complexity of the environment that might protect them from aggression as they develop their dominance, or as they provided a resource, then we get this increased aggression and problems there. And if we look at this group lactation system here, it might look quite idyllic in terms of behavioural expression, but actually there's huge problems for the piglets in these systems and huge amounts of piglet mortality. So these are the trade-offs that Francois mentioned. We have trade-offs evident in all systems, and whilst trying to allow for behavioural expression, we may have inadvertently had a go at the other freedoms and compromise those. It's also worth mentioning that this is a big problem if the systems are poorly designed. It's a bad thing, but it's also a good thing, because we can improve systems, we can work to improve systems to allow more free. So what can we do? What are the solutions? Well, we need more detail. We need to think about behavioural and physical information to create design data and then optimise systems. So we know that we can look at the flight path in great detail of a hen moving between perches, and we can look at where the damage might occur as she moves throughout her barn, and look at the pressure points for her keel and her feet, and then look at designing perches that might minimise that damage, adding additional furniture within the barn system to help them navigate throughout the barn with more care and therefore more protection for the other freedoms. In terms of the farrowing environment, we can combine physical data about the size of the animals. We know all this. It might be changing as we make them bigger, but we can look at body dimensions and then look at how they move within their environment to then create a space that doesn't have to be a necessarily massive space, but it has to be a dynamic and a complex space to provide different stimuli to try and improve maternal behaviour and then piglet survival. And that's the sort of work that we need to do now, optimising the systems. So is that the problem solved? Well, not completely, obviously. The way that we can try and affect change for a lot of animals is through stakeholder engagement. So one of the very important things we need to do is demonstrate the benefits of allowing behavioural expression. If you give animals choices, they may be able to achieve the same goals that the farmer wants and improve their biological fitness and therefore improve their productivity. We have to do that in the context of understanding, of course, the needs of the farmer and the consumer. And none of our efforts can be at the expense of other freedoms. Yes, there'll be trade-offs, but we have to think about that. And I don't want to finish on too much of a bum note here, but one thing I haven't really mentioned throughout is the fact that genetic selection strategies and the push for higher and higher productivity tends to move the goalposts. So we're having to deal with animals that are changing all the time, are under a lot of pressure, and we have to adapt the environments to still allow the 5 freedoms to be achieved effectively to enhance animal welfare. Thank you very much to Fritha and for Vicky Sandlands for my poultry pointers. Any poultry questions, definitely to Vicky. And we have a variety of funders and they're acknowledged as well. Thank you very much.
Thanks very much. Again, another pair of very interesting and fascinating talks. But in the interest of getting you to your lunch and not violating the first freedoms, I'm afraid I'm not going to allow any questions for this session either. Please do hunt them down and question them during lunchtime. So we will move on now to the final freedom, the freedom from fear and distress. And I'll hand over to Simon Turner, who will introduce that freedom to you.
Okay, thank you very much, Kathy. This doesn't sound like it's on. Is it on? Yep, good. Okay, thank you. Right, so yes, I've been asked to speak about the last of the 5 freedoms, the freedom from fear and distress. And as you can tell, all of the freedoms have challenges, and this one is no different. Not least the aspect of preventing mental suffering and what that means. So the title of this freedom is Freedom from Fear and Distress by ensuring conditions and treatment which avoid mental suffering. So there are several challenges here. Firstly, the stimuli that potentially induce fear and distress are fairly ubiquitous certainly in livestock production. There is an issue of how we measure mental suffering, and then there's the challenge of trying to minimize fear and distress under commercial production conditions. So I want to touch on these things. I also want to mention that fearfulness itself can compromise productivity, and I want to very quickly touch on the idea of reducing or removing the fear-inducing stimulus, or actually adapting the animals to cope better with them. So I mentioned there that fear-inducing stimuli are pretty commonplace. And why is that? Well, firstly, for our livestock species, we have to realize these animals are traditionally or historically predated animals. So they've evolved to be very fearful of things like humans and other potential predators. They don't like startling stimuli, isolation, or novelty. And if you think about a task such as belly clipping cattle, as in this photograph here, it involves all of those things. It involves close contact with a human, it involves a startling stimulus from the sudden noise of the clippers, it involves isolation, and it involves novelty of having somebody touching a very sensitive part of the animal's body. And in this particular case, each of those things is really quite unavoidable. You can't belly clip an animal without isolating it and without using clippers. Another aspect of fear and distress is that compromising any one of the 5 freedoms is likely to result in some degree of fear and distress. So compromising or resulting in hunger or thirst, situations that cause discomfort, pain, injury or disease, or that thwart normal behaviour, may result in fear and distress. So an animal which can't perform normal behaviour and where we have tail biting in a pen will probably result in some degree of fear and distress. So situations where aggression becomes excessive, and so on. So what do these challenging events mean to the animal? I'd firstly like just to show you a little video clip of a steer which is in a handling crate or a crush on what is actually a very good farm, and just to show you the kind of response that we see. Okay, clearly not a very happy animal. That animal had actually only been weighed. Nothing negative had happened to it particularly in there. And I'd like just for you to keep in mind that behavioural responses by individual animals like that occur on any farm, even very good farms, as in this particular case. So how do we, as animal welfare scientists, measure and record that kind of behaviour? And I talk about behaviour because I'm an ethologist, but there are other ways in which we can try and get a handle on fear and distress by using physiological measures that you've heard of previously. But I want to concentrate particularly on behaviour. So we can use some very simple approaches. We can use a scale such as this, a categorical scale. This particular one was designed such that we could record the animal's behaviour very quickly on large numbers of animals, and actually could even be used by commercial producers. The animal you've seen probably would have scored a 5 because of the constant violent shaking of the crush. And we can develop other methods that measure fear responses in other contexts. But I wonder whether this kind of scale, useful as they are, really gets to the heart of this freedom. Because if you remember, it says that we should avoid mental suffering. So that infers that we try to probe something about the animal's state of mind. And I think addressing that particular issue for this freedom, and indeed for all of the other freedoms, has been a stimulus for some of the most innovative welfare assessment approaches that we've developed globally, not just ourselves, in recent years. And I want to touch very briefly on a couple of them. They're behavioural examples, and they apply not just to this freedom, but indeed could be used for the other freedoms as well. You've heard about qualitative behavioural assessment already. I mention it again just because I think it gets us a little bit further into understanding the fear responses of animals beyond the kind of scale that I've just shown you there. Here we have 2 young cattle in the same handling crate, with a photographer standing in front of them in exactly the same way. Both of them are standing still. They aren't doing anything. They aren't shaking the crush. But they look subtly different. They would have been scored on that previous scale I showed you with the same score. But to me, they look subtly different. The one on the right seems to be showing more attention. Perhaps it's more anxious. It's perhaps more alert. So I think the value of things like qualitative behavioural assessment allows us to use terms like anxious in a way that is actually robust. Another very different technique which I'll mention has been used more in the context of measuring, of assessing depression, and it's to ask whether animals see the glass as half empty or half full. So it's a measure of cognitive bias, where animals are on the spectrum of optimistic to pessimistic. And we know that animals that are in a state of depression from chronic housing in a poor environment tend towards the pessimistic side of the scale. So in the context of fear or depression, we could use a test like this to look at the effects, for example, of constant subordination from ongoing life in a social group and the fear associated with that. So to do this, one scenario would be to train an animal to associate a white bucket on the left-hand side with a very pleasant food that it really likes. And at the same time train it that a black bucket on the other side of the pen contains nasty, horrible food, broccoli or cauliflower or something. And then what we do is we actually give the animal an ambiguous cue. So we give it a grey bucket and we place it in the middle between where the other 2 buckets previously were. And we say to it, okay, what are you going to do? Are you going to approach this kind of stimulus, or are you not going to, depending on whether you're optimistic or pessimistic? So far I haven't really spoken, apart from showing you that video, about individual differences in fear responses, but we see very, very large individual differences in fear responses in animals. This figure here shows you what happens when we release an animal from a weigh crate and allow it to move a distance of about 4 meters from the exit of that crush. And each of these little bars is data from one animal. So you can see these ones on the left hand side covered 4 meters, which is about here to that podium, in half a second from a standing start, which looks rather like they've been fired out of a cannon. This figure shows, it's the same kind of idea, but shows you something slightly different. This is the amount of time it takes for pigs to approach a stationary human in their home pen. And this time you can see some animals go straight up and touch the human within a second or two. Other animals take much, much longer. So again, we have this large variation, and these animals we would regard as being more fearful. What we find is that these individual differences are repeatable over time, and they're repeatable over different situations. So we would interpret that as being a fairly stable trait, probably reflective of personality. And this is determined by the genetics, by the genotype of those animals, and also by their pre- and postnatal development. And in the talk after this, you'll hear from Paula Brunton about how some of the prenatal effects can determine how animals respond in postnatal life to fear-inducing challenges. So what can we do about this? About the fact that these fear situations are out there and are very common. Well, I'll go back to the list that I mentioned before there. And I think there are some things we can indeed tackle. Some things are a bit harder. It may be the case that a lot of tasks we have to isolate an animal and inevitably involve some novelty. We can try minimizing the duration of the isolation. We can try exposing the animals to novelty in a more gentle manner. We can also think about simple things like startling stimuli. How many farms do we go to where we see things like string flapping around in front of an animal? Simply removing that kind of stimulus might actually reduce some of the fear that animals experience during handling. But a common thread throughout all of the handling situations that we perform on farms is that the element of the human contact. So we need to think about ensuring consistent, calm and quiet handling. And I've underlined consistent there because there's plenty of research shown that a single day of poor handling can undo many previous days of good handling. So consistency is really key. And I want to just really finish by emphasizing that reducing fear makes good economic sense. It's been shown time and again that particularly chronic fear can reduce growth and reproductive performance. And acute fear associated with poor handling during transport, and particularly the slaughter process, can very majorly compromise meat quality. And there was some work done quite a few years ago in Australia which showed the benefits of demonstrating quantitatively to farmers how their behaviour impacts the fear of the animals and then impacts economic productivity on farms. And by demonstrating that evidence to farmers on commercial farms, they actually found a 6% improvement in litter size after providing that evidence to farmers, and a 4% improvement in milk yield. So it makes economic sense. So just to conclude, the potential for fear-inducing events is ever present. Turn that on its head, and the opportunities for improving production by managing fear, I think, are also out there to be exploited. Assessing how animals emotionally experience fear-eliciting situations has, along with addressing the other freedoms, been one of the greatest stimuli for animal welfare scientists to try and probe the animal's state of mind. Some animals cope better with fearful challenges than others, and that's down to the genetic and developmental components. And it does present us with opportunities. There are opportunities to breed animals to cope better. For example, some breed societies in some countries of the world breed cattle to be less fearful when you handle them, for their own welfare, for handler safety, and particularly to improve meat quality. There may be ethical issues to consider there about whether we should actually be altering the handling process instead. And there may be opportunities to improve our management of the animals, particularly during the neonatal and prenatal period. But I think better stockmanship is probably the key thing that can be applied on most farms that will benefit all animals and will give the most immediate benefits in reducing fear. So I'd just like to finish by thanking the Scottish Government for funding this day and also for funding some of the work that I've touched on very briefly there. Thank you very much. I'd like just to now introduce Paula Brunton from the Rosalind Institute, who is going to finish off just before lunch, and one of your freedoms is compromised with hunger and thirst.
Can you hear? Yeah, that's working. Okay, so I'm going to follow on from what Simon's talking about. I'm going to focus on stress, and primarily stress that happens in early life, particularly during development. And I'm going to focus on stress in pregnancy and the long-term impacts that can have on the offspring. How do you change the slides? Okay. So touching on what Emma already told you about, changes in legislation resulted in, from the 1st of January 2013 in the EU, it said that pregnant sows could no longer be kept for the most part of the pregnancy in individual stalls, and instead they were going to be group housed. The problem that this can induce is that now sows are frequently mixed together with unfamiliar individuals, and this can result in aggressive behaviour and cause social stress in these animals. And what we can see is that animals can end up with body lesions such as those. So in the experiments I'm going to talk about, I'm going to talk a parallel study in some pigs and in some rodents. So in the pig studies that were performed by colleagues in SRUC, social mixing occurred for two 1-week periods, either during the second trimester of pregnancy or during the third trimester of pregnancy. And this social mixing involved pruniparous pigs, so their first pregnancy young sows, being exposed to older multiparous sows for these 2 1-week periods, either in the second or third trimester. And the rodent model that we were trying to create in parallel to try and establish whether we could use rodents as a tool to try and understand some of the challenges that livestock animals may present and understand the mechanisms that may underlie these long-term impacts, was a social stress model in rats. Now, generally female rats are not aggressive, except for during lactation. So during lactation, a female rat will become aggressive to any unfamiliar animal or conspecific that approaches the nest, and she does that to obviously protect her young. So by introducing a pregnant animal into the cage of an unfamiliar lactating rat, we can reliably induce a social stress in these animals. So this is an example here. This is what we call the resident rat. So this is her territory or her cage, and this is her pups. And when we've put in an intruder, she will attack it. And obviously this is stressful for this animal. So this is how we're inducing social stress in the pregnant rat, to try and have a comparative model of the social stress system in the sows. So first of all, we're interested in what's happening to the mother when she's experiencing stress. So we wanted to have a physiological measure of stress. So we measured stress hormone. So the hormone we were interested in was glucocorticoids in pigs, and in humans that hormone is cortisol, and in rodents such as rats and mice that's corticosterone. But essentially they're the same steroid hormones, just slight different structure. So as you can see in this second trimester, when the animals are mixed during this trimester, the maternal salivary cortisol levels are high, and when they're mixed in the third trimester you have an elevation in those animals, as you'd expect. And in the animals these are the rats where we socially expose them to social stress. So this is measurement from blood. We'd collected blood before 10 minutes after the stress and 30 minutes after the stress. And what we find when we average it over those 5 days that they were exposed to stress, that we see much more corticosterone secretion in the mothers exposed to the social stress. So the stress is increasing stress hormones in the mothers. We were also interested in what effect or what impact is that going to have on the offspring that are in utero at that time. in later life. We're particularly interested, sorry, I should just, that's another point that has already been mentioned by Emma, where we know that elevated cortisol or increased levels of stress is associated with impaired maternal behaviour, both in pigs and also in rats. And the studies referred to by Emma, by Susan Jarvis, it's shown that there's an increased instance of savaging of the piglets. And we also see infanticide in rats that are extremely stressed during their pregnancy. So the reason for being interested in the offspring partly was to do with a lot of interest coming from the human literature on the effects stress during pregnancy in women was having on the offspring, and it gathered lots of press attention. For example, studies looking at the babies who were born to mothers following the 9/11 terrorist attacks and so on. And in particular, one of the phenotypes that kept coming up is that babies or offspring whose mothers were stressed during pregnancy are more vulnerable to anxiety or anxiety disorders later in life. So we tested that in the rodent model first of all. To do that, we used this well-established test to establish how anxious a rodent is. There's a few available. This one's called the elevated pus maze. And for those of you who are not familiar with it, it consists of two intersecting arms. The two that would be here are the open, what we call the open arm, and the two here are closed. And they're elevated about a metre above the ground. And basically what this test does is test the animal's drive to explore, because they like to explore novel and new areas, versus its anxiety to go into an open area which is brightly lit, because obviously rodents are prey animals, and so they have this fear of being in open spaces, but they do like to explore. And these tests have all been validated using anti-anxiety drugs. So what we do is we put the offspring, these are now adults, in rat terms they're about 12 weeks of age. We take the ones who were born to mothers who weren't stressed during pregnancy, so are controlled, and those who were born to mothers who were stressed during their pregnancy. And what we find is the number of times, I should say, that the more time spent on these open arms, an animal is deemed to be less anxious than one that spends most of its time in these closed arms. And you can see that prenatally stressed offspring, they go on those open arms less than control offspring. And on the other hand, if you look at the time it takes to make the first entry onto the open arm, we can see prenatally stressed animals take much longer to make their first venture onto this open arm. So we would interpret these data as these animals are showing more anxiety-type behaviours than the control animals. We were interested in what could be underpinning this and what's changing in the brains of these animals to make them show this more anxious behaviour. So we focused on the amygdala. This is a part of the brain, and this is a cartoon of a rat brain, and it's in this region here. It's blown up from the rat brain, and then here it's the amygdala and the pig brain. And the amygdala is important for organising anxious behaviour. It importantly involves a peptide hormone called corticotrophin-releasing hormone, or CRH. So higher levels of CRH in this part of the brain, the amygdala, are associated with greater levels of anxiety behaviour. And there's lots of studies being done to show that with knockout rodents or infusions of CRH. There's also two receptors for this hormone. There's the type 1 receptor, CRHR1, and when that receptor is activated, that promotes stress responses, so it's present in the pituitary to drive the HPA axis, and it also promotes anxiety-like behaviour. So activation of this receptor would be expected to increase anxiety. The second receptor, the type 2 receptor, has the opposite effects. It tends to dampen stress responses and reduce anxiety-like behaviour. So we asked the question, are there changes to the gene expression for these this peptide and these receptors in the brain of these prenatally stressed rodents, first of all? And what we found is that gene expression for the ligand, CRH in this case, in the amygdala, maybe you can see in these illustrations, see these photographs, the black dots illustrate the gene expression. They have more of this pro-anxious peptide CRH than the control animals. Similarly, the receptor through which pro-anxious behaviour is mediated is greater there's greater expression in the prenatally stressed than the control animals. And finally, the receptor where we would expect to be activated to dampen anxiety behaviour is actually lower. So taken together, all these changes in gene expression would promote an anxiety phenotype in these rodents. We then went on to look at the same genes in the pig brain to try and validate whether these rat models would be a good model for the pig, and we found a similar pattern. So the CRH in the prenatally stressed pigs, so these are the pigs that were born to mothers who experienced the social stress during pregnancy, is higher. The type 1 receptor, which I told you is the one that promotes anxiety, is also higher. However, in this case, we didn't find a change in the type 2 receptor. However, the anatomy for the pig amygdala is not quite as detailed, so we have to probably do some more work on whether we can define the separate regions of the amygdala in the pig. But this is sort of supporting the data for these two from the rodents, that these animals are likely to show an anxiety-prone phenotype. We were also interested in stress reactivity in later life. How will animals whose mothers were stressed in pregnancy respond to stressful challenges later in life? So one of the things we did in the rodents was restraint stress. So these animals were blood sampled repeatedly. These two lower ones remained in their cage throughout. This grey bar represents a period of restraint. So they were put in a perspex tube for this 30-minute period, and we collected blood to measure stress hormones in that time. And as you would expect, they don't like being put in this tube, so there's an increase in stress hormones in the control animals, and then when they're removed from the tube, it starts to come back to normal. But in the prenatally stressed animals, the corticosteroid response is much greater, so suggesting that they're more responsive to the same stress challenge in adulthood. Susan Jarvis and other colleagues at SRUC had looked previously at the responsiveness to stress in later life in the offspring of the socially stressed pigs. So these pigs are now about 9 to 10 weeks of age, and they measured them in response to a brief period of social mixing, and where you can see this is the control animals' response, this is the time since the stress, and they're coming down. The response in pigs that were either born to mums mixed in the second or third trimester show firstly a larger or greater response, and moreover the response is prolonged, so it's still elevated 5 hours after the stress compared with the control animals. So together these data are showing these animals are more responsive to stressful challenges in later life, which presumably will have a negative impact on their welfare. We've done lots of mechanistic studies in rodents, and I'll not have time to go into all these today to try and understand what's going on in the brains that underlies these changes in responsivity to stress. But essentially what we find is that there's changes in the steroid pathways in the brain. In particular, one of the things we find is that the stress axis, normally when you have increased corticosteroid secretion from the adrenal gland in response to stress, that will feed back to the brain, to a part of the brain called the hippocampus, and act on receptors there to switch the axis off to try and stop the response getting out of control. What we find is the receptors that corticosteroid can bind to, expression of those in the brain is reduced, so it suggests the ability of the animal to switch off its stress response is impaired, so that may explain not only the greater responses but also the prolonged responses. Another enzyme we find that's responsible for making steroids in the brain is called 5-alpha reductase, and this is particularly relevant because the steroids that this enzyme can make are known to have stress suppressing and anxiety or anti-anxiety effects, and indeed when we replace animals by giving these steroids back, we can actually normalise their stress and anxiety responses. So I'll hopefully show you that rats can be useful tools for dissecting some of the mechanisms that underlie programming of systems such as the stress system and anxiety system as a result of an adverse environment in early life. Just before I stop, one quick final slide that may have relevance also for large animal species. This is a test of social memory in rats. And what we do here is, these are our test animals. We expose them to a same-sex juvenile. They've never encountered before. They have some time to investigate, and then after a predefined delay period, in this case 1, 2 or 3 hours, we repeat the test. The same juvenile as before is presented, but this time with a novel juvenile they've never met before. In rodents, if they remember the one that they've encountered before, they will now start to investigate the new one much more. And what we can see when we do this in control and prenatally stressed rodents is that in each case, our controls after 1 hour delay, controls and prenatally stressed have this preference to investigate the novel juvenile. Similarly, at 2 hours they can still do it, but prenatally stressed animals are getting less good. And by 3 hours, control animals still have a preference, so they can still remember this previously encountered juvenile, whereas our prenatally stressed animals can no longer tell the difference. So that indicates that there's some sort of social memory impairment. And given that social recognition and social memory is vital for forming a whole host of different relationships, social relationships in animals, for example, dominance hierarchies, this is a potential to have impacts for health and welfare for livestock species as well, because if these sorts of things translate to, for example, pigs, then we could see more aggression because there's some deficits in social memory. So I'm getting told to hurry up, so I'll skip to summary and just go to the final point, which I guess is to say that a major challenge going forward is to balance the trade-off between sow and piglet welfare. So by banning individual stalls in pregnancy, that was done to promote sow welfare, but as a result we now have negative welfare implications for the piglets in later life. And I'll stop there just by acknowledging lots of people that were involved in the studies I've presented today.
Thank you very much. And again, I'm afraid, in the interest of you guys ever getting any lunch today, I'm not going to allow any questions, but we do have a discussion session this afternoon. So if you have questions that you're really keen to ask, then do hold on to those. So lunch is available out the back. We have an extended lunch period, so we won't be back in here again until 2:45, and that is to give you plenty of opportunity to have your lunch, but also to, there's exhibitions out the back here, but also down the stairs and round the back here, and also in another room behind here, where there's lots of opportunity to get a bit more hands-on with some of the things that we do, to ask more questions. You can